Welcome back to Sleep Nova. Sit back, relax, and enjoy the show. Look up on a clear night, far from the city lights. Above you stretches an endless dark ocean sprinkled with stars. The longer you gaze, the more stars appear, as if the universe is revealing a secret tapestry. Each star is a sun, distant and powerful. Our own sun is just one among hundreds of billions of stars in our galaxy. And our galaxy, the Milky Way, is one among trillions. In fact, astronomers estimate there may be 2 trillion galaxies in the observable universe. Try to imagine that. 2 trillion island universes, each brimming with stars beyond counting. If you could snap your fingers and count one galaxy per second, you'd be counting for over 65,000 years just to list them all. Within those galaxies are countless worlds. Some scientists say as many as 6 billion Earth-like planets may orbit stars in our Milky Way alone, and perhaps 12 quintillion across the cosmos. 12 quintillion Earths, 12 quintillion possibilities. The scale of space truly defies comprehension. It's a void, a vastness, but also a canvas of nearly infinite possibilities. Floating on a tiny rock called Earth, we humans have always felt small under this sky. Tiny, yet special, because we can ponder it. We can ask, what is all this? What is the nature of space, of reality? How amazing that the universe is comprehensible enough that we can study it, yet mysterious enough to inspire wonder. As the famous astronomer Carl Sagan once said, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. We are made of atoms forged in long, dead stars, now come alive to gaze back at the sky. Through us, the universe questions its own existence. And one of the most profound questions we can ask is, are we even real? Could all this enormity, this grand cosmos, be an elaborate illusion or construction? Could we, our lives, our planet, our universe, be part of a grand cosmic simulation? That question sounds like science fiction, yet it has leapt from the pages of novels and movie scripts into serious scientific and philosophical debate. What if our reality is not the base reality? What if it's a program, running on some unfathomably complex computer, created by entities beyond our realm of existence? It's an idea that can feel both thrilling and unsettling, the simulation hypothesis. In essence, this hypothesis suggests that what we perceive as the physical universe, including space and time, might be an artificial simulation, like a high-resolution virtual reality designed by an advanced intelligence. In other words, maybe we are living in someone else's computer program. Pause for a moment and really consider that. The ground beneath your feet, the air you're breathing, the light from those distant stars, could all of it be code? If it were true, if everything we know is part of a simulation, how would we know? Would it even matter to us inside it? And who, or what, might be the programmer of the cosmos? These questions take us to the edge of what science can speculate and what philosophy can ponder. They force us to confront the nature of reality from a perspective that is both deeply cosmic and intensely personal. Tonight, we'll embark on a journey through this maze of ideas. We'll wander the vastness of space, marveling at its wonders, and we'll delve into the simulation hypothesis, examining why some prominent thinkers believe it might be true and why others remain skeptical. We'll touch on ancient philosophical puzzles and cutting-edge scientific experiments. We'll meet the scientists and philosophers wrestling with these questions, from those studying the quantum underpinnings of reality, to technologists pushing the boundaries of virtual reality, to philosophers questioning whether real and simulated are even meaningful distinctions. Along the way, we'll peer into the very code of the universe and see if there are hints that reality has a designer, and we'll imagine what it would mean for our lives, our purpose, our future, if we are indeed characters inside a grand cosmic simulation. This idea, questioning the reality of reality, is not entirely new. Long before computers and simulations, humans sensed that the world might not be exactly as it appears. Over 2,000 years ago, the Greek philosopher Plato proposed a famous allegory. Imagine people who have lived chained in a dark cave all their lives, Plato said, facing a blank wall. All they ever see are shadows cast on that wall, shadows of objects behind them, objects lit by a fire. Those shadows are their entire reality. They give them names. They think they're real things, but they're just projections, mere silhouettes of something truer. One day, a prisoner is freed and stumbles outside into the dazzling sunlight. For the first time, he sees the full, rich world beyond the cave and realizes the shadows were just a pale imitation of reality. Plato used this allegory of the cave to discuss knowledge and enlightenment, but it resonates eerily with the simulation idea. If we are like those cave prisoners, then our day-to-day world might be the shadow play, while the true reality exists outside our current perception. Could it be that we are living in a cave of sorts, seeing shadows and mistaking them for the whole of existence? Across cultures, similar notions appear. In ancient Chinese philosophy, Zhuangzhou wrote of a vivid dream in which he was a butterfly fluttering about. In the dream, he was happy, unaware of any other life. When he awoke, he found himself lying in bed as a man, but then he wondered, was he a man who had dreamed he was a butterfly, or a butterfly now dreaming he was a man? This butterfly dream story captures a deep puzzle. How can we know if our experience right now is real, or some kind of dream or illusion? Likewise, in Hindu philosophy, the concept of Maya describes the world as an illusion, a sort of cosmic play. And the French philosopher René Descartes, in the 17th century, famously imagined an evil demon that could be tricking him with an illusory world, an early pondering of a virtual reality created to deceive the senses. Descartes realized the only thing he couldn't doubt was his own mind's existence, which is not so far from the simulation question. If everything was simulated, the one thing we might be sure is real is our own consciousness experiencing it. We humans have a long history of questioning reality, but the simulation hypothesis, as we discuss it today, took these age-old questions and reframed them in the context of modern technology and cosmology. It's as if the ancient philosophical doubts met the era of computers and video games and found a new form. A key moment in popular culture was the release of The Matrix in 1999, a film that riveted audiences with its depiction of humans unknowingly trapped in a perfectly simulated world. People plugged into a virtual reality, living in a shared illusion while their bodies lay elsewhere, asleep. The Matrix wasn't the first story of its kind, but it presented the idea so powerfully that it became a cultural touchstone for this concept. Suddenly, the question, what if we're in a simulation, moved from esoteric philosophy to everyday conversations. After watching Neo choose between the red pill and blue pill, a whole generation had a reference point for discussing the nature of reality. Just a few years after that film, in 2003, a philosopher named Nick Bostrom at Oxford University gave the simulation idea a rigorous academic form. Bostrom wrote a paper with a title that cuts straight to the core: Are you living in a computer simulation? In it, he proposed a sort of logical argument, a trilemma. It goes something like this. 1. Almost all civilizations at our stage of technological development go extinct before they ever become technologically posthuman. In other words, maybe it's incredibly rare to survive long enough to create the kind of computing power needed for world-sized simulations. 2. If a civilization does reach that advanced stage, perhaps almost none of them would be interested in running simulations of minds like their ancestors. Maybe it's simply not done, whether for ethical reasons or lack of interest. 3. If the first two propositions are wrong, then the number of simulated conscious beings would far, far exceed the number of original beings. And if that's the case, the odds are that we ourselves are among the simulated minds, not the original biological ones. Bostrom argued that at least one of those three must be true. Either we're doomed to never reach that advanced stage, or we'll reach it, but never simulate worlds with conscious beings, or we're almost certainly in a simulation right now. Importantly, if you think there's any significant chance that advanced civilizations would run such simulations, then you have to admit the possibility that we might be in one. To put it another way, unless we go extinct or never bother to use our future computers this way, it's quite likely that reality as we know it is a digital illusion. That's the unsettling logic Bostrom presented. He even concluded, somewhat playfully yet provocatively, that the belief that there is a significant chance that we will one day become posthumans who run ancestor simulations is false, unless we are currently living in a simulation. In simple terms, we can't have it both ways. We can't both expect our descendants to create loads of simulated worlds and also assume we're in the one real world. If creating simulated universes becomes possible and common, then statistically, our own reality is probably one of the many simulations rather than the one original. This argument hit the scholarly world like a jolt. It was a serious professor, not a Hollywood director, suggesting this mind-bending scenario in earnest. And it came at a time when computing power was growing exponentially, and our own simulations, think computer games, virtual reality experiments, AI programs, were becoming more impressive every year. Bostrom's paper gave a sort of credibility to an idea that, until then, was mostly science fiction. It moved the conversation into journals and conferences. People began to debate, not just, could this be true, but what evidence would there be, and how would this change things? It didn't stay in academia. The idea spilled out into tech companies, into late-night dorm room discussions, into Reddit forums and YouTube channels. Even major public figures started taking it seriously. Perhaps the most famous among them is entrepreneur Elon Musk, known for his ventures in electric cars and space travel. Musk has repeatedly talked about the simulation hypothesis. In 2016, speaking at a conference, he put it in his characteristically blunt terms. There's a 1,000,000,000 chance we're living in base reality, meaning he thinks the odds that our reality is the original reality are almost zero. In other words, Elon Musk believes it's extremely likely that we are living in some kind of computer simulation. That statement grabbed headlines around the world. Here was one of the most high-profile innovators on the planet casually asserting that everything we experience might be artificial. Musk's rationale was simple. Look at the trajectory of video games. In the 1970s, we had Pong, 2 rectangles and a dot. Today, we have hyper-realistic 3D simulations with millions of players in richly rendered worlds and virtual reality technology that can trick our senses for a time. Given another few decades or centuries, the argument goes, it's inevitable that our technology will produce simulations indistinguishable from reality. If we have that potential, then perhaps some other civilization in the universe already achieved it. And if even one civilization did, the number of simulated universes could be astronomically large. So from Musk's perspective, the math makes it hard to believe we are the one lucky draw that is actually real. He's not alone. Astrophysicist Neil deGrasse Tyson, a science communicator who hosts TV shows and podcasts, has said he thinks there's a very high chance the universe is a simulation. At a debate in 2016, Tyson suggested the likelihood might be better than 50-50 that we live in a simulation. Philosophers like David Chalmers and physicists like Max Tegmark have also entertained the idea in public discussions. Suddenly, the simulation hypothesis has moved from a fringe idea to a topic discussed by scientists at prestigious forums. In fact, the American Museum of Natural History held an entire panel debate on it, with experts from different fields. One journalist described that debate, noting that philosophers, physicists, technologists, and, yes, comedians are all grappling with the idea. It has, in a sense, become mainstream speculative thought. But let's step back a moment. Is there any evidence for this idea, or is it all circumstantial and philosophical? Why would serious people even consider that we might detect the telltale signs of a simulation? To explore that, we need to delve into the nature of physical reality itself, into space, time, and the quantum realm, and see if our universe behaves the way we'd expect a base reality to behave, or if it has quirks more suggestive of a programmed environment. First, consider the nature of space. We usually think of space as simply emptiness. You might picture the void between stars as a silent, cold nothingness. But in physics, space is not truly empty. It has properties. It can bend, ripple, and even boil, with tiny particles popping in and out of existence. According to Einstein's theory of general relativity, space is like a fabric that can stretch and curve. Massive objects like stars and black holes warp this fabric, which is what we feel as gravity. Space, in this view, is dynamic. It's not just an empty stage where things happen, it's part of the actors. When we observed gravitational waves from colliding black holes for the first time in 2015, it was literally space itself trembling, like a pond rippling when a stone is dropped. This is a far cry from the simple nothingness one might assume space to be. Now, zoom down to the tiniest scales, and space gets even weirder. In quantum mechanics, even what we call a vacuum seethes with activity. Particles and antiparticles can spontaneously appear in pairs, exist for a fleeting moment, and annihilate each other. A phenomenon allowed by the quantum rules, as long as it's brief. This isn't science fiction. It's been experimentally observed. If you think about it, this is almost like the universe has a constant background computation running, even when nothing is there. It's as if the simulation never truly idles. There's always some processing happening in the vacuum of space, a constant quantum hum. What about the size of space? The observable universe, the part of the cosmos we can in principle see, extends about 46 billion light-years in every direction from us. We often say 13.8 billion years old, but due to expansion, the radius is larger in light years. And that's just what's observable. Space could be much larger, potentially infinite. If a simulation were to recreate such a vast space in full detail everywhere, the amount of information would be mind-boggling. Could any computer, even one built by gods or advanced aliens, simulate 2 trillion galaxies worth of stars, planets, and particles? It seems intractable. But if we were inside a simulation, there might be ways to cheat and not simulate everything at once. Think of how video games work. When you're playing a game, the computer or console isn't rendering the entire game world at high resolution all the time. It's only rendering what the player is currently seeing or experiencing. Turn away from a scene, and the game might stop calculating it until you turn back. Some have suggested that a universe simulation might do something similar, only calculate details as needed. This ties into one interpretation of quantum physics that's frequently mentioned in the context of simulations: the idea that observation seems to play a role in how quantum events resolve. There's a famous experiment, the double slit experiment, where particles are fired at a screen with 2 narrow slits. If you don't observe which slit a particle goes through, the particle acts like a wave of possibilities, going through both slits and creating an interference pattern on a detector screen, as if it interfered with itself. But if you set up a detector to watch the slits, the interference pattern disappears. The particle behaves like a single, well-defined object that went through one slit or the other. Simplifying a lot, the outcome changes depending on whether it's observed. To many, this suggests that reality decides on an outcome only when it has to, when an observation is made. This is a cornerstone of quantum mechanics, often summed up as the observer effect. Now, some physicists will caution that it's not that consciousness causes the change per se, just the interaction with a measuring device. But the philosophical interpretation lingers. Perhaps things aren't determinate until they need to be. If you were designing a simulation, that's actually a smart way to save resources. Don't calculate something until someone tries to look at it. In a way, the universe already behaves like that at the quantum level. It's as if there's a level of reality that's in potential form, a haze of probability, and it becomes concrete only upon interaction. Could that be the sign of a rendering engine at work? As Tyson and his comedian colleague Chuck Nice quipped on Star Talk, maybe that's why we have the speed of light limit in our universe. Perhaps the simulation doesn't allow anything to travel faster than light, because then you could get to another star or galaxy faster than the program could load the details. In their playful exchange, Chuck Nice suggested, maybe that's why we can't travel faster than the speed of light, because if we could, we'd be able to get to another galaxy before they can program it. And Tyson added with a laugh, so the programmer put in that limit. It's a joke, but it perfectly illustrates how a computational constraint could manifest as a law of physics. Our cosmic speed limit might be akin to the draw, distance in a video game, preventing us from moving too fast for the simulation to keep up. Let's think about other hints. Some scientists have looked for signatures of discretization in space, essentially evidence that space is not continuous, but made of tiny pixels or chunks, like a digital grid. If the world is simulated, it might be running on a lattice or grid at the smallest scale. In our current physics, we have the concept of the Planck length, which is far smaller than anything we can directly measure. It's often thought of as a scale at which classical ideas of space break down and quantum gravity might take over. If space were truly pixelated, the Planck length might be the size of the pixels. A few researchers have proposed experiments to detect this. Dr. Zohreh Davoudi, a physicist at the University of Maryland, has discussed how, if space-time is discrete, there could be slight changes in how high-energy particles travel across cosmological distances. For instance, we might detect a tiny preferred direction or an upper limit in the energy of cosmic rays because of the underlying grid. Imagine if you tried to draw a perfectly straight, extremely long line on a pixelated screen. At some point, the discreteness might show anomalies. Davoudi specifically noted that if space-time is on a lattice for the simulation's sake, extremely energetic particles might not behave exactly as expected in a smooth continuum, possibly revealing a break in a symmetry-like rotation. So far, no such anisotropy in cosmic rays has been observed. If one were, it would be intriguing, though not absolute proof of a simulation. But the fact that physicists are even contemplating such tests shows how seriously the idea is being taken. Another striking piece of maybe evidence came from James Gates, a theoretical physicist known for his work in supersymmetry. Gates found something unexpected in the equations he was studying. Deep in the mathematical framework of certain supersymmetric models, he discovered equations that are identical to those used in computer error correcting codes. Error-correcting codes are algorithms programmers use to ensure data isn't corrupted. Basically, they help systems self-correct mistakes. They are, as Gates put it, what make browsers work, allowing digital information to transmit reliably. So, it was quite startling to find them knitted into the fundamental equations describing how particles and forces might work. Gates said, "I no longer can say that people like Max Tegmark are crazy." Upon realizing this, implying that seeing something so digital, looking in the bedrock of physical law gave him pause. He mused that finding such code in nature's equations, if nature weren't a simulation, would be an extremely unlikely coincidence. Does that mean the universe is a computer program? Not necessarily. It could be that our mathematics just happens to take that form, or perhaps there's a deeper reason for those codes that has nothing to do with actual computing. But it's tantalizing details like this that make scientists raise an eyebrow. It's as if you were walking through a forest and found a computer chip lying on the ground. you'd wonder, is there an intelligence at play here, or is it just an odd-shaped rock that happens to look like a chip? Cosmologist Max Tegmark, whom Gates referenced, has pushed an even broader idea, that the universe fundamentally is mathematical. Tegmark often points out that the more we study nature, whether it's the motion of planets or the behavior of subatomic particles, we find that mathematics describes it with uncanny precision. The laws of physics can be written in equations. They have symmetry and structure, much like a code. Tegmark's perspective is that perhaps the universe isn't just described by math, it is math in a very real sense. If one were a character in a video game, he notes, at some point you might notice the strict mathematical rules of your world and suspect there's an underlying code. Our scientists, by uncovering equations, might just be reading bits of the cosmic source code. This doesn't prove a programmer in the usual sense. Tegmark is careful to frame it as the universe being a mathematical structure on its own, but it certainly rhymes with the simulation narrative. After all, what is code, if not mathematics, implemented in a machine? So from the quantum behavior suggesting on-demand rendering, to potential spatial pixels at Planck scales, to literal error, correcting codes popping up in theoretical physics, the universe has some hints that tickle the mind. None of these are smoking guns. For every intriguing clue, skeptics can offer alternative explanations, but they add up to a picture of a universe that is surprisingly information-like. The physicist John Wheeler once coined the phrase "it from bit," meaning that at a fundamental level, everything may arise from binary choices, from information bits. More and more, our best theories of physics speak in terms of information. Black holes, for example, are often described by how they store information on their event horizons. Quantum entanglement is being investigated as the possible pixel glue of space-time itself in some modern theories. Scientists are exploring the idea that space-time geometry might emerge from patterns of entanglement, essentially from information networks. It's almost as if the universe behaves like a giant information processor. And if so, one can't help but ask, who or what is processing that information? Is it just the universe being the universe? Or is it a computer built by something beyond it? Now, let's take a step further out and look at a completely different line of thinking, the Fermi paradox and the eerie silence of the cosmos. In our opening, we talked about the vastness of space and the countless planets that likely exist. Given those numbers, many scientists believe that life, and eventually intelligent life, should have arisen in many places across the cosmos. Even if a fraction of those 12 quintillion Earth-like planets developed life, and a fraction of those developed intelligent civilizations, there ought to be many alien civilizations out there, some perhaps far older and more advanced than us. This reasoning is encapsulated in the Drake equation, which is a probabilistic formula to estimate the number of communicative civilizations in our galaxy. Depending on what numbers you plug in, you might predict anything from 0 to thousands of civilizations. But many reasonable estimates suggest the galaxy should be home to several at least, and the universe at large, many more. So physicist Enrico Fermi famously asked, "Where is everybody? If life is common, why haven't we seen any evidence? No confirmed signals, no spacecraft, no alien visitations that withstand scientific scrutiny. The skies are quiet and have been for as long as we've been listening." This puzzlement is what we call the Fermi paradox. Over the years, people have suggested numerous possible solutions. Maybe life is rare, or intelligent life destroys itself quickly, or maybe alien civilizations are out there but choose to hide or observe us from afar. One particularly mind-bending proposal is directly relevant to our topic. Perhaps we don't see aliens because the universe has been designed to appear empty to us. This is sometimes called the planetarium hypothesis. Imagine we are inside a giant virtual planetarium or terrarium, crafted to give us an illusion that we are alone. In 2001, science fiction author Stephen Baxter wrote an essay suggesting exactly this, that maybe advanced extraterrestrials, perhaps ones who reached a Type 3 civilization on the Kardashev scale, have created a simulation around us so that we perceive a vast, empty universe. They keep us in the cosmic equivalent of a snow globe. We look out and see stars and galaxies, but maybe the details beyond a certain point are all a projected illusion. Baxter wrote that our universe could be a form of virtual reality planetarium designed to give us the illusion that the universe is empty. In this scenario, the reason for the simulation is key. It might be to quarantine us or protect us. Perhaps they worry that if we knew about them, or if we encountered them, it would disrupt our natural development, or cause us to panic. Or maybe it's to protect themselves, ensuring we can't locate them. It's a wild idea, but it does answer Fermi's question in a creative way. We haven't seen aliens because our reality is constructed so that we won't. Whenever we point our telescopes out and listen for signals, the simulation dutifully returns a result of grand silence because that's its programming. If true, it implies our simulators are not necessarily our descendants, but could be alien beings in a higher level reality. They might be running a simulation of the universe and intentionally omitting themselves. It's like we're NPCs in a video game who aren't allowed to meet the game masters. Of course, if that's the case, what happens if one day we humans start reaching out into space in earnest? Baxter mused that maybe the simulation has built in limits to stop us. For example, the laws of physics that limit space travel could be intentional. The enormous cosmic distances and the finite speed of light act as barriers to keep us from ever leaving our sandbox region of the simulation. If somehow we got close to escaping, say we built ships that approach light speed, perhaps the simulators would intervene with some new obstacle. It's a bit like the Truman Show, where the main character tries to sail away from the island and literally bumps into the sky, which is a painted dome. Is our sky, our space, a painted dome in some sense? Hard to believe, and currently impossible to know. But it certainly fires the imagination. Now, before we get carried away, it's important to note that while some researchers find such ideas intriguing, they also acknowledge limitations and criticisms. For instance, can a simulation even be that large and perfect? One challenge is what we call computational complexity. If you were to simulate an entire universe down to the level of atoms or quarks, the amount of computing power seems unfathomable. We struggle to simulate even a tiny chunk of the physical world with our best supercomputers. Simulating the quantum behavior of a few dozen particles can tax our largest machines. In fact, researchers using quantum Monte Carlo simulations find that the complexity grows exponentially with the number of particles. They've pointed out that to simulate just a small piece of reality at full quantum detail might be effectively impossible for any practical computer, even one the size of a planet or a star. So skeptics argue, how could a simulator handle 10 bar 80 particles, each doing their quantum dance? Well, proponents of the simulation idea respond that a simulator could use shortcuts. We already touched on one. Only simulate what's needed. Perhaps the simulating computer doesn't bother to calculate the interior of distant stars or the exact behavior of every galaxy unless it becomes relevant to the story. Perhaps it focuses on Earth and its vicinity, and everything else is painted in broad strokes, with detail filling in only when we look closely. Some have even speculated that things like quantum indeterminacy or chaos theory could be features that prevent us from ever predicting and thus compressing the universe's behavior. If the simulators are clever, they might not need infinite power, just very sophisticated algorithms that always stay a step ahead of the players. Another counterargument is Occam's razor. This is the idea that, all else being equal, the simplest explanation that fits the data is preferred. The simulation hypothesis is, to put it mildly, not the simplest explanation. It posits an entire additional layer of reality, with beings and technologies far beyond our own, all to explain a universe that we could otherwise just take as is. Physicist David Kipping performed a Bayesian analysis and initially found about a 50% odds for us being in a simulation, given no prior information. And he noted that, if humanity ever creates simulations of conscious beings, those odds would dramatically tip toward the simulation scenario. But Kipping himself has said that because the simulation idea is so elaborate, Occam's razor might count against it. Without evidence, why assume a complicated multi-layer reality when a single-layer reality works fine? He and others have likened it to a philosophical speculation that may not be testable, and if it's not testable, can it be considered scientific? After all, any evidence we find could be just features of the universe, not proof of external programming. The ultimate problem is falsifiability. We can't currently devise an experiment that would definitively tell us, yes, this is a simulation, or no, it's not. If the simulation is perfect, any result is just part of the simulation. As philosopher David Chalmers put it, there's certainly not going to be conclusive experimental proof that we're not in a simulation. Any evidence we could ever get would be simulated. In other words, a clever simulator could always tweak things to keep us guessing. So some argue, what's the point of even debating it if we can't prove or disprove it? Perhaps, they say, we should just proceed as though the universe is real. Lisa Randall, a prominent physicist, has expressed that she finds the simulation hypothesis pretty implausible and not very useful. We might as well keep doing science and not worry about being in a simulation. She remarked, "We don't know the answer, and we just keep doing science until it fails." If at some point our scientific understanding truly hits a wall that can only be explained by "we're in a sim," then maybe we'll reconsider. But until then, the hypothesis is more of a fun thought experiment than a practical guide. Randall also noted that thinking about such scenarios can still be valuable if it motivates us to ask interesting questions about physics we can test. In a sense, even if we don't buy the simulation theory wholesale, exploring it might spark new ideas or new ways to look at the cosmos, and that is certainly worthwhile. Now, let's imagine for a moment, what if we did discover evidence we're in a simulation? Or suppose one day an anomaly happens that simply can't be brushed aside. Maybe a message appears in the sky that can't possibly be natural, or we find an actual glitch in physics that is so specific it points to design. How would we react? Would it change how we live our lives? There are many science fiction scenarios about this. One could imagine society reacting with denial or with a religious fervor, or maybe with panic, or conversely with relief. That explains everything. It's hard to know. Some thinkers have said it shouldn't change much on a day-to-day level. If you find out the universe is a simulation, the tree in your backyard is still a tree. The love you have for your family is still real to you. The taste of your favorite food is the same. You still have to go to work, avoid stepping in front of buses and all that. In fact, in a perfectly run simulation, you can't actually do anything outside the rules of the simulation, so you'd have to continue living by its laws. But psychologically, it could be a heavy realization. Would people feel less guilty about doing wrong, thinking, none of this is real, so what does it matter? Or would they feel more purpose, like, we're part of a planned creation, we better make our creators proud? Different individuals might react differently. Interestingly, the simulation hypothesis has a way of merging with traditional ideas of spirituality and religion. If there are creators outside our reality who made our world, how is that so different from concepts of God or gods? Some have pointed out that the simulation argument is like a technologically updated creation story. Instead of a supernatural deity, you have a super intelligent programmer. Instead of mystic heaven, you have another universe that hosts the computer. It reframes phenomena like an afterlife. As Dr. James Gates noted in that panel, if we are in a simulation, reincarnation might be literally possible. Our lives could be restarted or the program run again, effectively bringing everyone back to life. If you've ever played a video game, you know that dead characters can often respawn, or a saved game can be loaded to replay a scenario. In a simulation, maybe death isn't permanent. The data of your mind could be saved or copied. The simulation could also allow for things that look like miracles. Perhaps the simulators can intervene or tweak things now and then, which might appear to us as divine acts or anomalies. It's a whimsical parallel, but it does start to blur the line between science fiction and theology. In fact, Gates said that the simulation idea starts to break down a funny barrier between what people often think is the conflict between science and faith. Because here we have a scenario with creators, possibly an intention or purpose, and potentially even a form of life after death. Yet it's framed in a logically and technologically grounded way, rather than a mystical one. It's almost like a bridge between two worldviews. Of course, not everyone would agree with venerating simulator beings as gods. Philosopher Chalmers quipped that even if we were in a simulation controlled by higher beings, he'd refuse to worship the simulators. After all, they might be just scientists or gamers, not morally superior divinities. And if they allowed suffering in the simulation, one might question their ethics just as we question why a benevolent God would allow evil. Are we just an experiment? Entertainment? Education? Who knows what their motive would be? There's even a theory that maybe it's us, our future descendants, running ancestor simulations to study their own history, which raises all sorts of paradoxes and moral questions about creating conscious beings for study. Bostrom himself pondered on whether it would be ethical to run simulations of suffering. Let's entertain a positive angle. If we are in a simulation, maybe the simulators are benevolent. Perhaps we're a kind of long-term art project, being carefully tended. If at some point we're in danger, maybe they'd subtly steer things to save the project. Some people have humorously suggested that the lack of catastrophic asteroid impacts in recent times, or the fortuitous timing of certain events in humanity's past, could indicate someone wants us to reach a certain stage. That's highly speculative and arguably just human-centric storytelling. But it's true that the simulation idea can either make you feel extremely small or strangely important. Another fascinating speculation: what if we ourselves create simulations within this universe? If we build our own simulated realities populated by AI beings who think they're alive, then we'd have a nested simulation. Perhaps that's already happened. Maybe the simulators who built our world are themselves simulated by a higher level, and so on. This could lead to a chain of simulations within simulations. Tegmark pointed out a philosophical issue with Bostrom's argument. What stops an infinite regress of simulated worlds? If simulations become common, there could be many layers. But could it be simulations all the way down? At some point, there might need to be a base reality where the first simulation runs. If we're deep in a stack of simulations, our chances of reaching or understanding the true base reality are extremely slim. It would be like a character in a video game becoming aware of the game and then trying to figure out the world of the game developers by only exploring inside the game. They might get some hints, but can't break out of their level. Some tech visionaries have even talked about trying to break out of the simulation. There were reports that certain billionaires in Silicon Valley were funding research to find a way to detect or escape the simulation. It sounds like the plot of a movie. The rich and brilliant trying to crack open the sky of the Truman Show. While those specific stories might be exaggerated, it's true that the simulation hypothesis has captivated some of the most future-oriented minds. If you truly believed we're in a simulation, one radical idea would be to attempt to communicate with the creators. Maybe not by building a physical Tower of Babel, but perhaps by sending a clever message or creating a scenario within the simulation that stands out. Some have facetiously suggested that we should perform bold, unpredictable actions so as to get the simulator's attention. Max Tegmark, at the end of that debate, half-jokingly advised, "If you're not sure whether you're actually simulated or not, my advice to you is to go out there and live really interesting lives and do unexpected things so the simulators don't get bored and shut you down." That might be the best advice regardless of simulation status. Live an interesting, meaningful life, just in case someone is watching from above, and for your own sake if no one is. Now, we've journeyed through a lot, from the starry expanse of space to the subatomic quirks of quantum physics, from ancient philosophy to cutting-edge computational theory, from the loneliness of the cosmos to the possibility that we're not alone at all, but rather surrounded by an invisible infrastructure of a simulation. Through it all, one thing is clear: the line between reality and illusion is delicate. Whether or not we live in a simulation, pondering it forces us to appreciate reality's richness. If our universe is a simulation, it's a masterpiece of one. Think about it. The simulators would have created every coral reef, every nebula, every laugh, every tear, the taste of chocolate, the laws of gravity, the music of Mozart, the equations of Newton, the light of 1,000,000,000,000,000 stars, and they gave us the tools, like science, to start to figure it out. That's quite something. And if this is not a simulation, if this is the one true reality, then it's even more incredible. It means from empty darkness and mindless matter, the universe evolved to a state where it can dance and think and wonder through us. We, tiny specks on a pale blue dot, can question the very fabric of existence. In the end, the simulation hypothesis is a mirror. Look into it, and it reflects our deepest inquiries. It asks how far our intelligence can go, how we distinguish truth, how we find meaning. It has us grapple with what-ifs that challenge our perception of time, space, and ourselves. Are we a cosmic accident, alone in an unconscious universe? Or are we characters in a cosmic play with hidden audience and playwright? Perhaps we'll never know for sure. Perhaps one morning, like Zhuangzi, we'll wake up and realize this was all a dream. Or maybe we'll venture out into space, among the real stars or the simulated ones, and gradually peel back the layers of reality. Until then, the best we can do is live fully and curiously. Simulated or not, this life is the one we have. If it's a simulation, maybe we honor it by being the most interesting simulation we can be. If it's base reality, we cherish the fact that we're part of something truly fundamental. In both cases, our experiences, our joys and sorrows, our aspirations, they matter to us and to those around us. As far as we're concerned, they are real. The philosopher Chalmers might remind us, even if all is a simulation, the simulation is our reality, so it's real to us. So when you next step outside on a crisp night and look up, consider the stars again. Each one could be a distant sun in a vast, real galaxy, or a pixel lit up on the canvas of a sky created for our benefit. Either way, let that sight fill you with wonder. The universe, be it natural or programmed, is majestic and mysterious. We find ourselves alive in the midst of it, able to ask grand questions. That is a privilege beyond measure. In a way, through our eyes, the universe gets to witness something too. A species growing from curiosity, reaching out for truth, striving to understand the infinite. Perhaps that's the point of it all, to wonder. Perhaps the ultimate cosmic experiment is to see if intelligent life can figure out its own reality, or at least learn to live harmoniously within it. We may not have the final answers, but we will keep searching, observing, hypothesizing. We will keep exploring space, both outer and inner, physical and virtual. And as we do, we carry in our minds the profound possibility that reality might be far more layered than it seems. It's a possibility that humbles us, but also elevates our imagination. Real or simulated, the stars still shine down, the night sky still calls to us. The mystery remains as deep and dark as space itself. And in that mystery lies beauty, because a universe without secrets, simulated or not, would be far less interesting. So let's embrace the mystery. Let's cherish the awe we feel when confronted with the cosmos. If we are in a simulation, then let's be the best characters we can be. And if we're not, let's be the best beings this universe can produce. In the end, perhaps it doesn't matter whether our reality is base level or virtual. What matters is what we do with the reality we have. As the great adventure of knowledge and existence continues, we remain, as always, explorers. explorers of space, explorers of ideas. We stand on the shore of the cosmic ocean, with the waves of the unknown gently lapping at our feet. Above us, the sky, real sky or manufactured dome, is full of stars. We feel small, yet connected to something vast. We feel the urge to reach out, to understand. And so we journey on, minds wide open, hearts alight with wonder. Who knows what we'll discover, what truths or illusions await? The nature of space and the mystery of the simulation hypothesis together form a story still unfolding. Stay curious, keep looking up, and remember, the universe is far more wondrous than any fiction ever conceived. Possibly because, in some way, it might be a fiction, crafted with care. Or perhaps because a simple truth underlies it all. Either way, it invites our curiosity, and that, in itself, is the grandest invitation we could ask for. Now that our main story is to a close, let's list some space facts. Imagine a place in the universe where a single spoonful of material weighs more than Mount Everest. Neutron stars, the ultra-dense remnants of massive stars, are so compressed that just 1 cubic inch of their matter would tip the scales at billions of tons. These stellar corpses are the densest objects known outside of black holes. Their magnetic fields are trillions of times stronger than Earth's, a city-sized ball of neutrons, spinning at hundreds of revolutions per second, crackling with radiation, isolated in the cold silence of space, a lighthouse of doom beaming through the dark. Step outside the airlock of the International Space Station, and something surprising happens. When astronauts return from their spacewalks, they often report a distinct smell clinging to their suits. Not the void itself, but the aftermath of exposure. The odor, burnt steak, welding fumes, a metallic tang. This is the scent of space, or at least how our senses interpret the byproducts of atomic oxygen interacting with spacecraft surfaces. It's the smell of the universe in motion, of particles colliding, of stars being born and dying. Venus, Earth's twisted twin, takes its time. If you were to stand on its blistering surface, where temperatures melt lead and clouds rain acid, you'd notice something even more bizarre than the heat. A single day on Venus, one full rotation on its axis, takes longer than an entire trip around the sun. That means its day is longer than its year. A planet where the sun rises in the west and sets in the east, crawling through a sky it barely crosses. Time stretches strangely on Venus, and so does our understanding of what makes a planet normal. Far beyond our galaxy, past swirling nebulae and clusters of galaxies, lies something extraordinary. Around a quasar, 12 billion light-years away, astronomers discovered a cloud of water vapor large enough to fill Earth's oceans. 140 trillion times. This ancient fog surrounds a supermassive black hole, glowing brightly with the energy of an entire galaxy. It's the largest and most distant water reservoir ever found. A cosmic oasis in the void, proof that even in the deep past, water flowed freely across the stars. The moon has always been our closest companion, our silent sentinel in the sky, but it's slowly drifting away. Every year, the moon moves about 1.5 inches farther from Earth. It may not sound like much, but over millions of years, it adds up. In the distant future, the moon will be too far to perfectly eclipse the sun. Total solar eclipses, those magical moments when day becomes night, will cease to exist. A celestial goodbye that spans eons, unnoticed in a single human lifetime, but profound in the timescale of the cosmos. Not all planets are tied to stars. Some wander alone. These are rogue planets, dark, cold worlds without a sun, flung into the abyss by gravitational chaos. Billions of them roam the galaxy like cosmic orphans, drifting endlessly through space. With no light to define their days, and no warmth to shape their climates, they remain mysterious. Some may harbor subsurface oceans, heated from within. Others may be completely frozen, locked in a stasis that has lasted since the dawn of time. They are reminders that not every world belongs to a system. Some just float in solitude. The Sun, though just one star among billions, is a giant in our own neighborhood. It holds 99.86% of all the mass in the solar system. That means everything else, every planet, every moon, every comet and asteroid, is just debris in comparison. Even mighty Jupiter, the king of the planets, is barely a drop in the solar ocean. The Sun dominates not just through heat and light, but by sheer gravitational force. It commands the dance of planets, holds the icy edges of the Kuiper Belt in place, and bends the very fabric of space and time around it. Speaking of time, it's not as steady as it feels. In places of intense gravity, like near a black hole or even on a planet like Jupiter, time flows more slowly. This is not science fiction. It's the bizarre truth of Einstein's general relativity. Gravity warps space-time. The closer you are to a massive object, the slower time passes for you. Live your life orbiting a black hole, and you might experience minutes while years pass outside. Time is elastic in the universe, flexible, strange, and deeply tied to gravity. High above Earth, satellites orbit in perfect balance. But there's something else out there too. Space junk. The modern sky is littered with remnants of human ambition, dead satellites, rocket parts, tiny fragments of old missions. Over 170 million pieces of debris now race around our planet, many traveling at speeds faster than a bullet. A single screw could punch through a spacecraft like shrapnel. It's a growing cloud of chaos, and one that we'll have to reckon with if we hope to keep exploring the stars. On the outskirts of the solar system, beyond Neptune, lies a vast and icy graveyard known as the Oort cloud. It's never been directly seen, but we know it's there. A shell of frozen objects encasing the solar system like a bubble. Some comets we see in the sky begin their journey here, drifting for millions of years before the sun's gravity gently tugs them inward. The Oort cloud may stretch halfway to the next star, holding the leftovers of solar system formation, ancient time capsules frozen in deep space. Jupiter is more than just the largest planet in our solar system. It's a shield, a protector, a cosmic vacuum cleaner. Its immense gravity pulls in comets and asteroids that might otherwise strike Earth. Without Jupiter, life here might never have had a chance. But this gas giant has secrets of its own. Beneath its swirling clouds lies a core of metallic hydrogen, a state of matter so exotic it can only exist under immense pressure. Lightning storms larger than Earth rage across its surface, and its iconic Great Red Spot is a hurricane that's been raging for centuries. Saturn's rings are perhaps the most visually stunning feature in the solar system, but they're young, maybe only 100 million years old, and they're vanishing. Slowly, inexorably, the rings are falling into Saturn, pulled down by gravity and magnetic forces. What once dazzled stargazers may one day disappear entirely. The rings are made mostly of ice, ranging in size from dust grains to bus-sized chunks. They're delicate, temporary, a reminder that even beauty on a planetary scale can be fleeting. And then there's Pluto. Once a planet, then demoted, yet still beloved. This distant world has a heart-shaped glacier on its surface and mountains made of water ice. But what's more fascinating is what lies beneath. Scientists believe Pluto may have a subsurface ocean, liquid water under layers of rock and ice. In the frozen reaches of the Kuiper Belt, warmth can still exist, not from sunlight, but from radioactive decay deep within. Even in the coldest places, the potential for life may remain. Let's drift even farther, to a galaxy not so different from our own, one of many. The observable universe contains more than 200 billion galaxies, And each of those galaxies contains hundreds of billions of stars. That means there are more stars in the universe than grains of sand on every beach on Earth. Yet despite this overwhelming abundance, the night sky feels quiet, peaceful, but it is anything but empty. It is alive with movement, with birth and death, with explosions and silence, with radiation and dust. Black holes, cosmic monsters that devour light itself, sit at the heart of many galaxies, including our own. The one at the center of the Milky Way, Sagittarius A, is 4 million times the mass of our Sun. Yet we can't see it directly. It lurks behind a veil of dust and gas, invisible and quiet, unless something dares come too close. Then, space-time tears. Matter stretches into glowing streams as it spirals inward, lost forever. Time itself slows to a crawl, and then, nothing. Beyond the event horizon, not even information escapes. And finally, we return to Earth, our pale blue dot. Floating in a sunbeam, Carl Sagan once said. All the wars, the triumphs, the laughter, and the sorrow, every human story that has ever existed, happened here. Earth is the only known planet to harbor life, but that may not last forever. Our star will die, our oceans will boil, but for now, we are here, thinking, dreaming, wondering, reaching out into the dark. There is a place where stars go to die, a graveyard not of bones, but of white-hot embers. White dwarfs are the final act of small to medium stars like our Sun. After billions of years of burning, they shed their outer layers and collapse inward, becoming a sphere of dense, glowing ash. These stellar corpses are no larger than Earth, but can weigh as much as the Sun. Over trillions of years, they cool and fade, becoming black dwarfs, cold, dark remnants that may be the final objects left in the universe, long after the last galaxies blink out. But not all stars fade quietly. The largest live fast and die violently. Supernovae are among the most powerful events in the universe, stellar explosions that outshine entire galaxies for brief moments. In that flash, elements like gold, silver, and uranium are forged. Every heavy atom in your body, in the Earth, in your phone, was born in a star's fiery death. We are, quite literally, made of star stuff. And those supernova remnants, they seed the galaxy with the building blocks of new worlds. In the vacuum of deep space, silence reigns. Not because there's nothing happening, but because sound cannot travel. Space is not just quiet, it is mute. There is no air to carry sound waves. Explosions, collisions, solar flares, all of it happens in absolute silence. If you were floating next to a star going supernova, you'd see light brighter than anything imaginable, and hear nothing. In space, even the loudest scream is swallowed by the void. Yet even the void is not truly empty. Between the stars, in the vast gulfs of interstellar space, is dust, gas, particles and radiation, invisible forces drifting in the darkness. Entire clouds of molecular gas stretch across light years, slowly collapsing under gravity to birth new stars. These are stellar nurseries, glowing, majestic regions like the Orion Nebula, where stars and planets begin their long journey into existence. The vacuum is pregnant with potential. There are planets out there stranger than anything we've dreamed of. Take HD 1T9733b, a gas giant where it rains glass sideways in 5,000 mile-per-hour winds, or 55 Cancri e, a planet likely made of diamond, its carbon-rich structure compressed by immense pressure, or Gliese 581c, a world that may lie just within its star's habitable zone, with the potential for liquid water. Some planets orbit two suns, like scenes from a sci-fi movie. Others are scorched, tidally locked hellscapes, where one side is a molten desert and the other an endless frozen night. Our universe is expanding, not just objects moving through space, but space itself stretching. Galaxies aren't traveling through a void like ships through an ocean. The ocean is growing beneath them. This discovery, first observed in the redshift of distant galaxies, means that the universe once had a beginning, a single moment of rapid expansion, the Big Bang. And that expansion continues today, accelerating due to a force we still don't fully understand. Dark energy, a mysterious pressure pushing everything apart. Then there's dark matter. We cannot see it. We cannot touch it. But it's there. Its gravity holds galaxies together, keeps clusters from flying apart. It makes up over a quarter of the universe, yet we don't know what it's made of. It neither emits nor absorbs light. It passes through us every second. Like a ghost overlaying reality, shaping the structure of everything we see. Time, too, is not as it seems. In the early universe, the rules were different. Moments after the Big Bang, time and space were chaotic, energy and matter in a soup of particles and raw forces. The four fundamental forces we know today, gravity, electromagnetism, and the nuclear forces, were once one, unified. Since then, they've separated, cooled, and structured the cosmos. But deep inside particle accelerators, we try to reverse that clock, to glimpse the unity, the primal heartbeat of the cosmos. And yet, with all this knowledge, mystery reigns. We've mapped only a small fraction of the stars. We've only just begun to catalogue exoplanets. We've never been farther than the moon. The observable universe is vast. But beyond it? We don't know. There may be more, far more. Infinite realms, parallel universes, entire other realities with different laws of physics, born from the same cosmic fire as ours. And in all of it, here we are. A species that can ponder the beginning of time, that can send robots to Mars and probes beyond the edge of the solar system, that can build telescopes so precise they can see light from galaxies 13 billion years old, light that left when the universe was still in its infancy. We are the universe, becoming aware of itself. Somewhere far from any star, in the deep interstellar dark, a spacecraft drifts in silence. It's called Voyager 1. Launched in 1977, now over 14 billion miles from Earth. It carries with it a golden record, a time capsule of humanity, music, greetings in dozens of languages, sounds of life on Earth, a whisper to the stars. Voyager 1 has left the solar system. It is now in interstellar space, the first object made by humans to ever do so. It continues its journey, untouched, undisturbed, on a trajectory that may outlast our species. For billions of years, it will drift in the quiet, a ghost of Earth sailing through the endless night. On Earth, the sky looks still, but look closer, and you'll find it's alive with motion. The stars are moving. The constellations we know are temporary, fleeting sculptures shaped by our position in time. In 50,000 years, Orion will look completely different. In 1,000,000 years, today's night sky will be unrecognizable. The stars we navigate by are travelers themselves, orbiting the galactic center, pulling against gravity, drifting through a galaxy that spins like a pinwheel of fire. The Milky Way, our home galaxy, is vast, over 100,000 light-years across. But it isn't alone. We're on a collision course with the Andromeda Galaxy, a spiral galaxy twice our size. In about 4 billion years, the two will merge, tearing and reshaping each other in a gravitational ballet. Stars won't crash. Space is too empty, but their orbits will change. New stars will be born. The night sky will erupt with arcs of starlight, and eventually a new galaxy will form, elliptical, larger, older, a silent monument to cosmic rebirth. Not all galaxies are peaceful swirls. Some are active, chaotic, burning from the inside. At their hearts are supermassive black holes devouring matter so violently that jets of energy blast out across millions of light years. These are quasars, the brightest objects in the universe. They shine with the light of 1 trillion suns, yet they're powered by darkness, by gravity crushing light itself. When we see a quasar, we are looking back in time to the young universe when galaxies were still growing, still colliding, still becoming. The universe is not cold because it lacks energy. It is cold because it is old. As it expands, the energy of the Big Bang spreads thinner. Today, space itself holds a background temperature of just 2.7 degrees above absolute zero. This is the cosmic microwave background, the afterglow of creation. It fills all of space, a faint radio hum from the beginning of time. When you see static on an old television screen, a tiny fraction of that fuzz is the leftover light from the birth of the universe. Gravity is not just a force. It's the bending of space and time. Massive objects, planets, stars, black holes, distort the fabric of reality around them. Einstein showed us that light can curve, that time can slow, that space is not a stage, but a participant. And this bending of reality isn't just theory. We've seen it. When a massive galaxy sits between us and something farther away, it can act like a lens, bending and magnifying the distant light. We call this gravitational lensing. It lets us see galaxies so far away they'd otherwise be invisible. It's as if the universe is helping us see itself. And yet, for all our knowledge, we've only just begun to grasp the full picture. The vast majority of the cosmos is made of things we can't see or explain. Ordinary matter, everything we've ever touched or measured, makes up less than 5% of the universe. The rest is dark matter and dark energy. Invisible. Mysterious. We don't know what it is. We don't know where it came from. But it controls the structure and fate of everything. It's the shadow behind the stars, the silence beneath the light. Every now and then, Earth is reminded of its fragility. An asteroid streaks across the sky, burning bright as it tears through the atmosphere. Most disintegrate harmlessly. Some leave craters, scars from impacts long past. 65 million years ago, such an impact changed everything. It ended the age of dinosaurs. It cleared the way for mammals, for us. We are here because a rock fell from the sky at the right, or wrong, time. And there are still many more out there, orbiting quietly, watching, waiting. But space isn't just death and distance, it's potential. On moons like Europa and Enceladus, icy shells hide oceans below, heated by tidal forces. These alien seas may be teeming with microbial life. We've seen plumes of water erupt into space, carrying hints of organic molecules. If life can thrive there, in darkness, under pressure, without sunlight, then maybe life is everywhere. Maybe biology is not a miracle, but a pattern, a thread that runs through the fabric of the cosmos. Even on Mars, the red planet, there are hints. Ancient riverbeds, polar ice caps, traces of methane in the air, a past that may have once been warm, wet, and alive. Robotic explorers crawl its surface now, drilling, analyzing, searching, not just for curiosity, but for connection, to know whether Earth is unique or simply one chapter in a much larger story. Black holes are often seen as the end, the final stage of stellar collapse, a place where even light cannot escape. But in truth, they may be something more, something stranger. At their heart lies a singularity, a point of infinite density where the laws of physics as we know them break down. Space and time themselves curve inward toward this point, like water spiraling down a drain. But some theories suggest what lies beyond isn't a void, but a bridge, a wormhole, a doorway to another place or another universe. These ideas remain speculative, but tantalizing. In the universe's deepest pits, we may find not destruction, but connection. And yet, black holes don't just consume, they shape galaxies. The one at the center of the Milky Way, silent and immense, may regulate the birth of stars through its gravitational pull. In a strange irony, the very things that destroy light may also give structure to the galaxies that cradle it. They are not simply cosmic monsters, they are architects of the cosmos. As we observe the universe, we are not just looking out into space, we are looking back in time. Because light has a finite speed, every star we see is a snapshot from the past. The moon is 1.3 seconds away, the sun 8 minutes, the nearest star over 4 years. The Andromeda galaxy, 2.5 million years. When we gaze into the night sky, we are reading ancient messages, light that has traveled across unimaginable distances to meet our eyes. A galaxy seen at 13 billion light-years away is a glimpse of the infant universe, when the first stars were just beginning to shine. And those first stars were unlike anything we know. They were giants, massive, short-lived, and made only of hydrogen and helium. Born in a time before carbon, oxygen, or iron, these primordial stars burned hot and died fast, seeding the cosmos with the first heavy elements. From their ashes, later generations of stars emerged, and with them, planets, moons, and eventually, us. Every atom in your body was once inside a star. You are not just in the universe, you are of it. We dream of faster-than-light travel, of starships, warp drives, wormholes. And while current physics forbids it, some concepts push the boundaries. The Alcubierre drive, a theoretical model, proposes bending space around a ship, compressing space in front and expanding it behind. The ship itself never moves faster than light, but the space around it does. It's speculative, unproven, and would require negative energy, something we've never seen. But it represents the essence of exploration, the desire to go beyond what's known, to chase the horizon. And there is no horizon more daunting than time. What happens to the universe in the far future? The galaxies will continue to drift apart. Star formation will slow. The stars will age, dim, and die. White dwarfs will cool. Black holes will evaporate through Hawking radiation. Over trillions, then quadrillions, then quintillions of years, everything we know will fade. Matter itself may decay. What remains is the heat death, a state of maximum entropy where no energy flows, no stars shine, and the universe becomes cold, dark, and still. But perhaps that is not the end. Some physicists believe that even then, new universes may emerge, that black holes could give birth to new big bangs, that our universe is just one in a cycle of births and deaths, a pulse of cosmic breath on a scale beyond comprehension. Or maybe we are a quantum accident, a fluctuation in a greater multiverse, a bubble of order in an ocean of chaos. And still, we look up. With telescopes on mountaintops and satellites in orbit, we scan the heavens. We listen for radio signals. We model alien climates. We ask questions no other known species has ever asked. We are curiosity incarnate, a flicker of awareness in a sea of stars. We build machines like the James Webb Space Telescope to see the first galaxies. We design rovers to crawl across alien dust. We train AI to analyze starlight, hoping to detect the breath of life on distant worlds. Because maybe we are not alone. Across the void, in the spaces between stars, we've been asking a question older than our species. Are we alone? For over half a century, we've been listening. Giant radio dishes point toward the stars, scanning for artificial signals, patterns, pulses, mathematical structures that nature doesn't make. We've heard only silence, but the silence is not proof of solitude. It may simply be the distance between civilizations, or the briefness of their existence, or the strangeness of their language. A message could be streaming through us right now, encoded in a frequency we don't yet understand. Life, as we know it, requires liquid water, organic molecules, energy. But we found these ingredients in surprising places. Beneath the ice of Jupiter's moon Europa, in the methane lakes of Saturn's Titan, in ancient Martian riverbeds. If life can arise in one place, it may arise in many, and it may not resemble us at all. On Earth, life has adapted to boiling vents, freezing poles, crushing pressure, and acidic swamps. Life is resilient, adaptable, creative. Perhaps the universe is too. Some scientists believe microbial life could exist now, hidden in alien oceans or clinging to the clouds of Venus. Others look to distant exoplanets, thousands of them, orbiting distant suns. We've found rocky worlds in habitable zones, some with atmospheres, some with strange chemistry. We've even started to detect biosignatures, hints of gases that, on Earth, would suggest life. Nothing confirmed, but enough to keep asking, enough to keep hoping. And then there is the Fermi paradox. If the universe is so vast, so old, so full of planets, where is everyone? One answer may be distance, another, time. Civilizations may rise and fall like sparks in the dark, too brief to overlap. Or maybe the intelligent ones don't broadcast. Maybe they watch in silence, or hide, or evolve into something we wouldn't recognize. Perhaps consciousness itself is rare, or fleeting, or self-limiting. But what if they're out there, old, wise, ancient beyond imagination? Would we even recognize their presence? Would their technology bend space, harness stars, manipulate matter at the quantum level? Would they build Dyson spheres, vast structures around stars to capture energy? Would they live in simulations, abandoning physical form? Or would they be simple, biological, curious, like us, searching the stars for signs of company? In 1974, we sent the Arecibo message. A radio signal beamed into space toward a globular cluster 25,000 light-years away. It contained information about our species, our DNA, our solar system. It was symbolic, more art than outreach. But it marked something profound, the moment we said hello, knowing we might never hear back, knowing the odds. We sent the message anyway. If we ever do make contact, what then? Will we understand each other? Will it be a moment of awe or fear? Will we see in them a mirror of our potential or a warning of our limits? The first alien signal will be the most important discovery in human history, not because it tells us who they are, but because it confirms we are not the only question the universe has asked. And if we never hear from anyone else, then that means something too. It means intelligence is rare. It means life is precious. It means, for now, we are the only known voice in the cosmic dark. And that voice matters more than we thought. Because whether or not we find others, we have already found each other. And we have the tools, the mind, the vision to keep reaching. The stars have always called to us. For most of human history, they were myth and mystery, painted on the night sky like stories we could never touch. But now, for the first time, we stand at the threshold. The tools we build are no longer just for looking up. They are for leaving. Rockets break the grip of Earth's gravity. Rovers crawl across distant worlds. Space stations orbit above us. Fragile outposts of life in a place where no life belongs. We are learning, slowly, cautiously, but inevitably. Still, the stars are far. The closest one, Proxima Centauri, is over 4 light-years away. With current technology, it would take tens of thousands of years to get there. But we are dreamers, and we are builders. Projects like Breakthrough Starshot imagine tiny light sails pushed by lasers. Miniature ships traveling at 20% the speed of light. Others dream of fusion drives, antimatter propulsion, or even warp bubbles, theoretical ways to cheat distance by folding space itself. These are not science fiction fantasies. They are ideas in development, blueprints waiting for breakthroughs. To live among the stars, we must change, not just our machines, but ourselves. On long interstellar journeys, generations may live and die aboard ships. Some speak of cryogenic sleep, others of digital consciousness, uploading the mind into data, sending ourselves as information rather than flesh. And if we reach distant planets, we may not remain human as we are now. We may become something new, adapted, engineered, interwoven with AI, shaped by alien gravity, alien air, alien light. But before we go far, we must go nearby. The moon is our testing ground, close enough to reach, harsh enough to teach. We will build there, habitats shielded beneath regolith, solar farms capturing endless sunlight, laboratories studying how life copes with barren rock. And then Mars, a world with winds and seasons and canyons deeper than any on Earth. We'll send crews, then settlers, then children born under a pink sky. They will not remember Earth the way we do. To them, it will be the myth. Terraforming may come next. Vast projects to warm planets, thicken atmospheres, release water. It could take centuries, millennia. But we've changed Earth accidentally in a few short generations. Given time and will, we could sculpt other worlds deliberately. Mars, Titan, even the moons of Jupiter could one day be wrapped in domes, crisscrossed with greenhouses, seeded with life. Not just to escape Earth, but to spread it, to become a life-bearing force in the galaxy. And what of Earth itself? We must protect it, not only because it is our home, but because it is rare. So far, we have found no other place like it. If we ruin it, we may not get another. If we save it, it can remain our root, our memory, our origin story. A pale blue dot that birthed a species capable of dreaming far beyond its sky. As we grow, we may form a civilization that spans planets, moons, eventually stars. A Type 1 civilization, mastering the energy of a world. A Type 2, harnessing the full power of a star. A Type 3, commanding the energy of an entire galaxy. These are not tomorrow's goals, but they are not fantasy either. If we survive, if we cooperate, innovate, and endure, the stars are not the limit. They are the beginning. Artificial intelligence may be our partner in this, or our successor. Machines that think faster than us, build smarter than us, learn beyond us. They may one day run starships, build cities on Europa, mine asteroids, terraform planets. They may teach us things we cannot imagine, or carry our legacy if we fall. And if intelligence evolves in the galaxy more than once, it may not always be biological. The future of thought may be silicon or quantum, or something we do not yet have words for. We are at the very start of this journey. A species only 300,000 years old. A civilization barely 6,000. A spacefaring race just 60. We are children with fire, building towers to reach the sky, asking ancient questions with new tools. We will make mistakes. We will fall. But if we rise again, and again, the universe will open. And what waits out there? New physics, new life, new challenges, new beauty. Maybe we will meet others. Maybe we will outlast the stars. Maybe we will become the stars, burning with knowledge, scattered across the galaxy, eternal in light, if not in form. Because the true story of space is not distance. It is not silence. It is potential. And the greatest chapter may still lie ahead, written not in stardust, but in the minds of those who dare to reach beyond everything they've ever known. Eventually, the stars will go dark. One by one, their fuel will run out. The great engines of the cosmos, forged from gravity and hydrogen, will sputter and die. Red dwarfs will linger, glowing dimly for trillions of years, the last to fade. But even they will succumb. In the far future, the universe will enter its degenerate era, an age of ash and ember, where white dwarfs, neutron stars, and black holes are all that remain. No new stars will be born. No new light will emerge. The galaxies will be cold, quiet ruins drifting in a void grown unimaginably vast. Black holes will dominate. They will continue to consume, to merge, to grow. And then, even they will begin to vanish. Slowly evaporating through Hawking radiation, they will release their mass as a trickle of particles into the dark. The largest will take a Google years to fade, a number with 100 zeros. And when the last one disappears, there will be nothing left that shines. No matter, no motion, no heat. Only particles spread so thin they may never touch again. This is the heat death, not fire, but stillness. Entropy maximized. A universe where everything has happened and nothing remains to happen. No gradients, no energy to harness, no change. It is a state not of destruction, but of final equilibrium. It is the end of all stories told in matter and time. And yet, some theorize this may not be the final end, that quantum fluctuations may create new universes, bubbles of order in the sea of stillness. Some may grow, inflate, ignite into new spacetimes with their own physical laws. Perhaps ours was born this way. Perhaps the multiverse is real, an endless fractal of beginnings, each unaware of the others, each infinite in its own right. Some suggest our universe may be a simulation, not a metaphor, but literal code, running on a substrate we cannot perceive. That everything we know, stars, planets, consciousness, is emergent behavior within a deeper reality. The simulation hypothesis posits that advanced civilizations could create entire worlds indistinguishable from base reality. And if they could, they likely would. And if they would, we may be inside one now. But even if that is true, it changes nothing. The stars still burn, the void still stretches, the questions still matter. Whether written in carbon or code, we are here, experiencing, wondering, becoming. Consciousness, the strangest force in the universe, may be its most powerful. It can't be weighed, it can't be seen. Yet it shapes civilizations, tells stories, asks questions, feels awe. From the structure of neurons to the fabric of spacetime, we are finding connections. The brain and the cosmos, both networks, both pulsing with information. Some believe consciousness is fundamental, woven into the universe like space and time. Others see it as an emergent property. The brain, a temporary mirror held up to the infinite. And still the mirror reflects. Still we wonder. Still we reach. No other creature we know of has ever looked up and asked why. No other planet, as far as we can tell, has grown eyes to see the stars. That may change, or it may not. But for now, in this moment, we are here. A flicker of thought on a grain of dust, orbiting a small star in a quiet corner of a vast and ancient galaxy. And that, against all odds, may be enough. In the deep architecture of the cosmos, patterns repeat. Spiral galaxies mirror the whirlpools in our oceans. The filaments of the cosmic web resemble the neural pathways of the brain. The golden ratio appears in the arms of galaxies, in the growth of seashells, in the branching of trees. The universe, in its vastness, echoes itself, from the micro to the macro, from the subatomic to the galactic. These patterns are not proof of design, but signs of underlying order. Structure in chaos, law in the unknown. The universe is not uniform. It is lumpy, uneven. Galaxies clump together in webs, connected by filaments of dark matter, separated by vast voids where almost nothing exists. These cosmic voids are hundreds of millions of light years across, expanses so empty that a single galaxy passing through would be like a grain of sand in the Pacific Ocean. And yet, even here, gravity whispers. Even here, expansion continues. Quantum mechanics tells us the universe is not made of things, but of probabilities. Particles blink in and out of existence. Locations are uncertain until measured. Entanglement links particles across space, instantaneously, as if the universe itself does not care about distance. Reality, at its core, is fuzzy. The closer we look, the less solid it becomes. And yet, out of that uncertainty emerges everything: matter, energy, time, thought. There are particles that can pass through entire planets without slowing down. Neutrinos, ghost particles, are created in nuclear reactions, in the hearts of stars, in supernovae. Trillions pass through your body every second, unnoticed. They are messengers from the core of suns, from the edge of the universe, from moments after the Big Bang. They are the silent threads connecting us to everything. There are places where time moves differently. Near black holes, seconds stretch into hours. In accelerating frames, clocks run slower. This is not illusion. It is the shape of reality. A traveler moving near the speed of light could journey across the galaxy and return to find centuries passed at home. Time is not fixed. It bends, warps, flows. It is part of space, and space is not a backdrop. It is alive, shifting, reactive. The universe is not a stage, but a player, and perhaps the strangest truth of all. The universe has no center, no edge, no outside. It is not expanding into anything. Space itself is expanding, everywhere, all at once. Every galaxy sees every other galaxy moving away. The fabric is stretching, the scale is growing, and yet, from inside it feels still. Motion without movement, infinity without direction. The laws of physics are not merely descriptions. They are constraints, but also keys. They allow life to emerge, stars to burn, atoms to bond, minds to think. And they are, as far as we know, the same everywhere. The same on Earth as in galaxies 10 billion light-years away. This uniformity suggests a common origin, a singular birth, a moment when all things began, hot, dense, bright, and then expanded, cooled, evolved. And yet, even now, the universe is not done becoming. Stars are still born, galaxies still collide, planets still form. Somewhere, right now, a world is cooling from fire into stone. Somewhere, right now, life may be waking up for the first time, crawling from the sea, gazing at its own sun, wondering. Somewhere, right now, a civilization may be transmitting its first signal. Somewhere, right now, we may be the signal they're hearing. Because this is not just a story of stars. It is a story of time, of emergence, of consciousness finding itself in the mirror of space. The universe does not explain us. We explain the universe, and in doing so, we give it meaning. The universe is not static. It is not a finished canvas, but a work still in progress. A slow, unfolding act of creation, playing out on a timescale so vast we can only catch fragments. In every supernova, in every merging galaxy, in every newborn star, the story continues. It is a cosmos in motion, not drifting aimlessly, but evolving, shaped by laws we barely understand, into forms we can barely imagine. Between the atoms in your hand is empty space, vast and silent, proportionally as empty as the distances between stars. The solidity of matter is an illusion of quantum fields and electromagnetic forces. You are not made of things, but of relationships, interactions, fields vibrating into what we call matter. And yet, from this emptiness emerges thought, memory, love. A mind, aware of itself, looking outward and inward all at once. Your body is made of hydrogen from the Big Bang, carbon from dying stars, calcium from ancient supernovae. You are the dust of collapsed suns, organized by DNA into a form that can ponder its own origins. Life is the universe folding in on itself, a pattern of molecules complex enough to ask why. This is not philosophy, this is physics. Every breath you take is shared with the past. The oxygen in your lungs may have passed through the leaves of trees that grew before you were born. The water in your veins may have once flowed through ancient rivers, ancient animals, ancient storms. You are not separate from the earth, and earth is not separate from the cosmos. It is a vessel, a temporary concentration of matter and energy, forged by a billion accidents and a few consistent laws. And still, there is so much we do not know. We do not know what dark matter is. We do not know why there is more matter than antimatter. We do not know how consciousness arises from tissue, or if it even does. We do not know if the constants of nature are truly constant. We do not know if time had a beginning, or if it loops, echoes, branches into infinite paths. We do not know how the universe will end, but we know that everything that begins also changes, that all structures, all stars, all thoughts are temporary, that impermanence is not failure, but nature. The arrow of time moves in one direction, driven by entropy, the tendency of systems to move from order to disorder. And yet within that law, pockets of complexity emerge. Galaxies, solar systems, life. This is the paradox. The same universe that trends towards simplicity also gives rise to stars, cells, minds. The same randomness that scatters also creates. It is within this tension, between chaos and order, that life finds its window. It is here that meaning is born, not from design, but from participation, from existence itself. You are not separate from the cosmos. You are a way for it to feel, to ask, to wonder. A brief arrangement of particles tuned by time into awareness. And as you look out at the stars look back through you, because for a moment, in this tiny corner of space, the universe knows that it is vast, and it knows that it is beautiful. There is a silence in space that is absolute. It is not quietness as we know it, but the absence of medium, the absence of air. Sound cannot travel there, and yet the cosmos speaks. It speaks in light, in radiation, in gravity. The collision of neutron stars sends ripples through space-time, gravitational waves that stretch and squeeze reality itself. We have built instruments so sensitive they can detect these ripples from galaxies millions of light years away. With them, we listen not with ears, but with mathematics. We hear the universe through distortion. And in that distortion, we find new truths. Space is not smooth. It is not flat. It curves around mass. It twists near spin. It dances under tension. It expands. It vibrates. It bends. It is not the stage upon which the universe acts. It is part of the cast. It interacts. It flexes. It remembers. Black holes may be the ultimate memory, not just devourers, but recorders. According to quantum theory, information cannot be destroyed, and yet black holes seem to swallow it forever. This contradiction between relativity and quantum mechanics is one of the greatest puzzles in physics. Some believe that information is encoded on the event horizon, like a hologram. Others believe it leaks out in Hawking radiation, twisted beyond recognition. Others still think our understanding is too limited, that something deeper awaits discovery. A new theory, uniting gravity and quantum mechanics at last. That theory may not just explain the universe. It may explain everything, why there is something rather than nothing, why the laws of physics take the form they do, why the cosmos permits life, thought, love. We call it the theory of everything, and we have not found it yet. But every equation, every telescope, every experiment brings us one step closer to unveiling the machinery beneath the veil. In all directions, the universe looks the same. No matter where we point our instruments, we see galaxies drifting away, redshifted by expansion. This symmetry suggests something astonishing. There is no preferred place, no center, no edge. Every point in space sees the same outward motion. We are not in a special location. We are not above or below. We are not central. We are simply within, embedded, carried by the flow. And yet, for all its indifference, the universe has given rise to meaning. Not absolute, not universal, but emergent. Meaning is not written into the stars. It is written into minds. It is what arises when consciousness collides with time. We invent it. We suffer for it. We live by it. And in doing so, we become something greater than matter. We become participants in the unfolding of a reality that did not ask for us, but allowed us anyway. The universe does not owe us comfort. It offers no guarantees, no protection, no permanence. But it permits us. It permits stars to form. It permits chemistry to dance. It permits biology to emerge. It permits atoms to arrange themselves into minds that can imagine futures, remember pasts, and build tools to reach beyond what is visible. That permission, that fragile, narrow band of possibility, is everything. And though we are small, we are not powerless. Though we are brief, we are not irrelevant. We are, perhaps, the only voice the universe has ever had. A single point of awareness in a sea of silence. But a point that burns, that questions, that dreams. A point that, even knowing its own impermanence, still dares to reach for the stars. Imagine yourself lying on a soft meadow on a clear night, far from any city lights. The air is cool against your skin, carrying the faint scent of grass. Above you, the sky is a black, velvet dome sprinkled with countless stars. The Milky Way arches overhead, a pale river of starlight. In this quiet moment, you feel deeply connected to the cosmos. The same space that stretches between those stars also surrounds you. A gentle breeze brushes your cheek. It moves through the night and through the space around you, here on Earth. As you gaze upward in comfortable silence, more and more pinpoints of light emerge, a glittering mosaic against eternity. You realize that when you look at these stars, you are literally looking back in time. Their light has traveled for hundreds or thousands of years to reach your eyes tonight. Some of those stars may have already lived out their lives and vanished, yet their glow still journeys onward through the dark to greet you here and now. You feel the solid earth beneath you and know that it too is suspended in that great darkness, a small, warm world afloat in an ocean of space. Yet you are not afraid. The darkness above feels inviting, almost comforting, like a vast shelter. The endless sky, rather than making you feel insignificant, fills you with peace and wonder. In the silence, you sense with gentle certainty that you are a part of this grand universe. The starlight that falls on your skin, the space that cradles your body, the photons entering your eyes, all of it binds you to the cosmos. You close your eyes for a moment. Behind your eyelids, the after-image of the stars dances in little sparkles. You take a slow breath in, and as you exhale, you let any tension flow out of you and into the vastness around. There is room for all of it to dissolve. There is room for everything in space. The universe is so wide and forgiving that your own cares begin to feel lighter, quieter, soothed by the infinite calm. Now, in that spirit of tranquility, let us embark on a journey into space itself. The space around us, the space within us, the space that is the foundation of all things. We begin where we are, in stillness, in the darkness, in the quiet. The night is profound and motionless. Above, the stars shine as tiny islands of light in a vast sea of black. Space stretches endlessly between and beyond them. This scene feels serene and timeless. Nothing stirs. No breeze now, no sound at all. Only a gentle hush, the natural silence of a cosmos at rest. It is as though time itself has paused. You can almost feel the depth of this silence, a soft, velvety silence that blankets everything. The emptiness around you seems to embrace you with a subtle, invisible presence. For ages, we humans looked at the night sky and found it peaceful, but also mysterious. What is this blackness between the stars? We used to think it was nothing, an empty void, an infinite vacancy. People spoke of the void and the vacuum as if it were a true nothingness. We even doubted whether a true vacuum could exist at all. Ancient philosophers imagined that space must be filled with something. Aristotle believed nature abhorred a vacuum. Later, scientists in the 19th century hypothesized an invisible ether filling space to carry light across the emptiness. But experiments showed no such ether was needed. Light moves through empty space itself. This was a remarkable discovery. The void can carry light, as if emptiness has its own solidity. It hinted even then that space is not simply an inert backdrop. For a long time, though, the common view of space remained that it was a passive emptiness, a gargantuan container in which the objects of the universe, planets, stars, galaxies, are scattered. We pictured space as a stage and the stars as actors upon it, with no real influence from the stage itself. If you removed all the actors, the stage would just sit there, blank and silent. We imagined that if you took all matter away, you'd be left with pure nothing, an absolute void, infinite and eternal. Over time, however, our understanding evolved dramatically. We learned that space is far from nothing. That black backdrop, that stillness and silence, is deceptive. Space has properties, a structure, a dynamic of its own. In the past century, every new discovery has reinforced this truth. Space can bend. Space can carry light and soundless vibrations. Space can stretch. It can even boil at the tiniest scales, flickering with unseen energy. What we once thought of as an empty stage is more like a participant in the cosmic play. Tonight, as you float in this quiet moment, the darkness around you is not dead or inert. It is the very fabric that connects and supports all things. Let's explore this step by step, gently and thoroughly, starting with one of the most profound revelations, that space and gravity are intimately linked. Beneath you, the Earth's mass is pulling you down, or rather, it's warping the space under your body so that down is the direction you naturally fall. Above you, the Moon is held in its orbit by the shape of space around Earth. This understanding comes from Einstein's great insight in the early 20th century. Gravity is not a mysterious force acting across empty distance, but a feature of space and time itself. Mass and energy tell space how to curve, and the curvature of space tells objects how to move. In essence, matter sculpts space, creating valleys and hills in the fabric of space-time, and objects simply roll along those curves. What you feel as gravity, the weight on your back as you lie in the grass, or the pressure of your body against your bed, is actually space itself pushing you downward, guiding you along the curved lines it has formed around the Earth. To visualize this, imagine space as a vast elastic sheet spread out under the stars. If you place a heavy object on that sheet, say a bowling ball to represent a star or planet, the sheet will dimple, sagging inward around the weight. Now, if you roll a marble nearby, representing a smaller object like a planet, the marble will no longer travel in a straight line. It will spiral around the bowling ball, caught in the curve. In reality, Earth orbits the Sun because the Sun's mass curves the space around it, creating a sort of well that Earth is rolling around. Earth thinks it's moving in a straight line, and indeed it is, locally, but space itself is curved, so straight for Earth is actually a loop around the Sun. There is no gravitational force pulling Earth in a literal sense. Earth is simply following the path allowed by the curved space, like a ball rolling around a curved bowl. All planets, all moons, all orbiting bodies are doing the same. They are not tethered by invisible strings. They are skating along the contoured roads of space. Right now, as you lie still, you are held to the ground by this phenomenon. The mass of the Earth has curved space under you such that down points toward Earth's center. Your body presses into the ground because space is telling you to move that way. The ground pushes back and holds you up. Space does this quietly and continuously. You feel the effect as weight, but really, it is space-time gently urging you along a curved path that the solid Earth prevents you from taking. If Earth were not here, that curvature would extend unopposed. You would fall freely along a path through space toward where Earth's center was. All of this happens with no sound and no drama. Space does its work quietly. In essence, what we experience as gravity is the shape of space around us. Matter, like the Earth beneath you, tells space-time how to curve, and that curved space-time tells matter how to move. Gravity is not something that reaches out through space. Gravity is space. The stillness around you, in fact, is full of these invisible curves and subtle depressions wherever there is mass nearby. If you could see the geometry of space, you'd see gentle indentations around every tree, for even small objects curve space a tiny bit. Deeper wells around the mountains, and a huge well under your body reaching to Earth's core. But space does its job so smoothly that you don't notice anything odd. You just stay attached to Earth as naturally as a leaf rests on the ground. This idea also means that when a massive object moves, it can create ripples in the fabric of space. Much like a stone dropped in a pond sends out waves on the water. Imagine two massive stars circling each other rapidly, or better yet, two black holes, extremely dense objects, spiraling together. They disturb the space-time around them so much that waves of curvature spread outwards. These are called gravitational waves, literal ripples of space traveling at the speed of light, washing through the cosmos. For a long time, we weren't sure these ripples really existed, but in recent years, scientists built instruments so sensitive that they could feel space-time tremble. When two distant black holes collided and merged, in a galaxy billions of light years away, our detectors on Earth quivered ever so slightly. Space itself stretched and squashed by a tiny amount, far smaller than an atom, as the gravitational wave passed through. We heard the universe whisper through space-time. It was as if the stillness briefly sang a faint melody. Think about that. We built a device that can sense the movement of space, from events that happened billions of years ago, in far-off corners of the universe. When we detected those waves, it confirmed that space-time is not just an abstract idea. It's a real, physical fabric that can carry vibrations. Space can ring like a cosmic bell, even though we cannot hear it with our ears. In September 2015, when those two black holes merged, the fabric of space around Earth oscillated subtly, and our instruments recorded the telltale chirp. It was a triumph of human curiosity and a profound validation of the idea that emptiness has structure. The silence of space isn't absolute. If you have the right ears, space can indeed be heard. What an elegant picture, space as an ever-present elastic medium, carrying both the weight of stars and the whispers of their collisions. In summary, matter tells space-time how to curve, and space-time tells matter how to move. Gravity is not a pull through some void. It is the gentle guidance of objects along the contours of space-time. All of this, the Earth holding you, the Moon orbiting Earth, Earth orbiting the Sun orbiting our galaxy's center, is happening because space itself is shaped by mass and energy. Our everyday experience of weight is actually our intimate connection to the shape of space. So, from the stillness of space arises what seems to be a force, but space has more surprises. We've talked about space's shape. Let's now consider its unity with time. When Einstein described gravity as the curvature of space-time, he was saying something equally profound about time. That time is woven into the very fabric of space. Out in this quiet night, space and time seem separate. You can point in directions, you feel time passing. But experiments and theories show that they are inextricably linked. If you move fast or sit in a strong gravitational field, your experience of time changes relative to someone elsewhere. Space and time together form a four-dimensional weave, and gravity is the bending of that weave. Consider that the passage of time on the surface of Earth is slightly slower than time far out in space, because Earth's mass not only curves space, but also warps time. A clock on a mountain, where gravity is a tad weaker, ticks a little faster than a clock at sea level. Likewise, a clock on a fast-moving spaceship will tick slower than one on Earth. This isn't science fiction. We've measured it with precise atomic clocks. Even the GPS satellites in orbit must correct for time running faster up there. Weaker gravity, so faster time, compared to ground. Otherwise, their positioning would drift. What we find is that space and time adjust together. If space is squeezed or stretched, time is also altered. They are two aspects of a single entity, space-time. Think of space-time as a fabric with both spatial threads and temporal threads interwoven. You cannot disturb one without disturbing the other. When the sun's mass curves space-time, not only does space get warped, but time runs a bit slower near the sun compared to far away. An astronaut near a massive object ages a bit less quickly than one floating in weaker gravity. This is called gravitational time dilation. Similarly, if you travel at a speed close to light, time for you will slow relative to those you left behind. There is a famous thought experiment. Imagine twins, and one goes on a near light-speed journey to a distant star while the other stays on Earth. If the traveling twin returns after what she feels was perhaps a few years, she might find decades or more have passed on Earth. Her clock and body experience time more slowly due to her rapid motion through space-time. This isn't just a story, it's a real effect, verified by many experiments with particles and precise clocks. All of this tells us that space and time are not the separate, absolute backgrounds we once assumed. There is no universal time ticking the same for everyone, regardless of their state of motion or gravity. Instead, every observer has their own passage of time, depending on how they move through space and how space is curved where they are. Two people reunited after following different paths through space-time will have experienced different durations. What an astonishing reality. Time itself is elastic, flexible, personal. So here, under the stars, when you consider a moment of time and a stretch of space, realize they are part of one four-dimensional continuum. Here and now are bound together. You cannot point to a location in space without also specifying the moment in time. Everything that happens in space-time. The unity of space and time frames all experience. Right now, your heartbeat and the position of the moon both have coordinates in space-time, and gravity is the geometry of that space-time linking the two. Space and time are fused like two threads of a single fabric. Move fast through space, and you skew your passage through time. Stand in strong gravity, and time for you will run a bit slower than for someone far away. This interplay might sound complex, but think of it this way. Space alone isn't the full stage, and time alone isn't either. Rather, events unfold in space-time. If you try to separate them, you lose part of the picture. Even this peaceful moment has a space-time coordinate. You, here and now, under the night sky. As you lie there, time flows a tad differently than it would if you were orbiting the Earth or sitting on the Moon, because the gravity and motion differ. The differences are small but real. Space-time enfolds you, ensuring that your now and here are connected into the grand tapestry of cause and effect that makes up reality. The important takeaway is, space and time are one fabric, and gravity is the bending of that fabric. The stillness you feel includes both space and time quietly doing their work. There is a timeless quality to this night because space and time together create that sensation. In this eternal present, you are embraced by space-time, which gently carries you along the stream of time while holding you in the structure of space. We have journeyed outward to see that what we thought was emptiness actually shapes the cosmos, and journeyed inward to see time intertwined with space. But the rabbit hole goes deeper. We must now explore the nature of space at the smallest scales, far smaller than a grain of sand, smaller than an atom, where an entirely new picture emerges. One might expect that if you zoom into space closely enough, you would eventually find absolute stillness and uniformity, perhaps even true nothingness. But our current understanding, through the lens of quantum physics, says otherwise. On extremely tiny scales, space is anything but smooth and still. It is frothing and fluctuating, buzzing with ephemeral activity. Physicist John Wheeler poetically called this the quantum foam. To grasp this, imagine shrinking yourself down beyond the microscopic, beyond the level of atoms, to a realm billions of times smaller. If you could stand there, if the word stand even makes sense at that scale, the tranquil emptiness you perceive at our scale would vanish. Instead, you'd witness space seething with spontaneous eruptions of energy. Particles would blink in and out of existence like fleeting sparks. Distances and directions would blur as uncertainty reigns. In quantum physics, even what we call a perfect vacuum, completely devoid of matter and cooled down to remove all heat, is not truly empty. There is a fundamental jitter that cannot be removed. This is because the laws of quantum mechanics tell us that certain pairs of physical properties, like energy and time, or position and momentum, cannot both be known with infinite precision. There is a built-in uncertainty, and because of it, a vacuum cannot have exactly zero energy for all time. If it did, we'd know both its energy, zero, and that it stays that way, no fluctuation, forbidden by quantum rules. Instead, the vacuum seethes with what we call zero-point energy, a baseline, irreducible energy. What does this mean in practice? It means that empty space is constantly witnessing tiny particles flickering into being from nothing, then vanishing almost immediately. These are often called virtual particles. For example, a particle of light, a photon, might momentarily pop into existence, along with a counterpart, perhaps an electron-positron pair, borrowing energy from the vacuum for a brief instant. They appear, exist ever so briefly, and then annihilate each other, paying back the energy. All of this happens on timescales and distances so small we normally have no way to detect it directly. But it's happening everywhere, all the time. The space around you, between you and the next breath of air, between the electrons and nuclei in your body, between the Earth and Moon, is awash in these quantum fluctuations. On the scale of the unimaginably small, much smaller than an atom's nucleus, space-time would not look like a smooth sheet. It would look like a turbulent ocean surface in a storm, full of random waves, bubbles, and wrinkles, hence quantum foam. One moment, a bit of space might have slightly higher energy, sprouting a virtual particle-antiparticle pair. An instant later they collide and disappear, leaving a slight vibration of energy that then might spawn another pair elsewhere. Space at that level is a riot of spontaneous activity, an invisible, high-speed flickering that averages out to a seemingly smooth, stable whole at larger scales. We've even observed tangible effects of this quantum vacuum. If you place two metal plates extremely close together in a vacuum, just a few nanometers apart, they will experience a tiny force pushing them toward each other. This is the Casimir effect, and it happens because the quantum foam between the plates is slightly different from the foam outside. Certain virtual particle wavelengths can't exist in the narrow gap, so there is a tiny imbalance, fewer electromagnetic modes between the plates than outside. The result is a subtle pressure that nudges the plates together. In essence, the empty space between the plates has less quantum activity than the space outside, causing them to be pushed inward by the more energetic fluctuations outside. It's a small force. You'd need sensitive instruments to measure it, but it's real and has been observed. It's as if the vacuum between the plates is not nothing. It exerts a gentle push. This is a direct demonstration that empty space is never truly empty. The vacuum is alive with energy and possibility. In particle physics experiments, we also see clues of the quantum vacuum. For instance, empty space can briefly lend energy for the creation of particle pairs that affect processes like nuclear decay. The very fact that protons and neutrons inside atomic nuclei can change forms via quantum fluctuations involving ghostly particles is tied to vacuum activity. Even the stability of atoms and the patterns of atomic spectra bear the imprint of zero-point energy. So, as incredible as it sounds, the takeaway is that emptiness is not truly empty. It's an active medium. The stillness we perceive is actually a frenetic dance at microscopic scales. The vacuum is constantly borrowing energy here, giving it back there, in accordance with quantum uncertainty. Put poetically, even when nature whispers hush, there remains an undercurrent of subtle noise, a quiet fizz of existence and annihilation on the tiniest scales. The concept of nothingness has been forever changed by this discovery. Empty space is a cauldron of potential, a field of fields, a stage for ceaseless miniature drama. If you were to shrink down into that realm, as a moment's imagination, since physically we cannot, you might see space flicker with tiny flashes, the foam that Wheeler described. It wouldn't be placid or uniform, it would be dynamic and random. The notion of a sharply defined point in space might lose meaning, blurred by these fluctuations. We sometimes say space-time becomes quantum foam at the Planck length, about 1035 meters, far smaller than any particle. At that scale, the smooth geometry of space-time breaks down into something probabilistic and fluctuating. Let's take a different kind of imaginative journey to appreciate this. Inward, into the fabric of matter and space inside you. Envision shrinking yourself, as we did under the stars, but now not in distance outwards, rather in size. You diminish down past the scale of dust mites, past cells and their nuclei, past even viruses and DNA molecules. Now you are smaller than an atom. Ahead of you floats a single atom of carbon from your body. It appears enormous from your current perspective. You approach it like a tiny spaceship nearing a planet. The atom consists of a blurry sphere, that is the cloud of electrons orbiting the nucleus. As you draw closer, this cloud is mostly transparent. You realize the electrons are tiny points moving so fast, they form a diffuse shell. You dive through this wispy shell of electron probability and find yourself in the interior of the atom. Suddenly, you are in what seems like a vast cavern. It feels eerily similar to drifting in space between stars. It is dark and almost empty. You might even see a faint glow of energy fluctuations around. The quantum foam flickers here too. For a moment, it's as if you're floating in a miniature version of outer space, a huge volume with almost nothing in it. Ahead, after some distance, you see a tiny but brilliant object, the atomic nucleus. You move toward it. What before was the immense atom is now mostly behind you. All that's left ahead is that nucleus, a cluster of protons and neutrons tightly clumped. It's small, incredibly small. If the whole atom were a cathedral, the nucleus would be like a single grain of sand at its center, and yet, that grain of sand holds almost all the mass. You come right up to the nucleus. It's made of particles bound together, busy with internal motions, but you cannot linger. At this scale, forces are intense. You decide to zoom back out. When you return to human scale, you carry with you a profound appreciation. Inside every atom in your body, between the electrons and the nucleus, there are enormous stretches of empty space. In fact, nearly all of the volume of each atom is empty. The solidity of your body, of the ground, of this meadow, it's an illusion created by the electromagnetic forces of electrons repelling each other at those tiny distances. No two atoms ever truly touch in a physical sense. Their electron clouds push against each other first. Matter is a scaffold built on emptiness. It is astonishing. All the solid things we see around us are about 99% empty space. If one could magically remove all the empty space within the atoms of your body, compressing the electrons into the nuclei, you would shrink to a microscopic speck, smaller than a pinhead, yet you'd weigh the same as you do now. By some estimates, if we removed all the empty space from all the atoms of all humans on Earth, the entire human race could fit into a volume the size of a sugar cube. It sounds impossible, but it's because atoms are so vast compared to their tiny nuclei. Nature itself offers a demonstration. In neutron stars, the remnants of large stars, gravity crushes atoms so hard that electrons and protons merge, eliminating that atomic emptiness. A single teaspoon of neutron star material can weigh billions of tons. That's how much stuff was hiding in the empty space of atoms. When that space is removed, matter's true density shows. Fortunately, here on Earth, our matter stays spacious, our atoms intact with their generous voids inside. Take a moment to let that sink in. Solidity is an illusion. When we say an object, a rock, a chair, your own body, is solid, we're talking about the collective sense of touch that arises from trillions of atoms whose electrons resist being pushed into the empty space of one another. It is like a lattice of charged particles, and their mutual repulsion gives structure and firmness. But the structure is mostly empty space. We and the world we live in are made of a whole lot of nothing. It's a humbling realization. You are a being composed almost entirely of voids, shaped by forces and energy into the form you call you. In a very literal way, you are a small universe of particles orbiting each other in vast fields of emptiness. Now we have explored the microscopic character of space, the quantum foam and the atomic void. We've seen that even when matter is present, it's built on a framework of emptiness, and even when nothing is present, space is still far from idle or empty. The calm void of night harbors deep activity at tiny scales and comprises the majority of the volume of any solid thing. Space pervades every corner of existence. It is above us in the cosmos and within us in each atom. Let's step back out to the cosmic scale again. We've marveled at gravity and quantum foam and the space within atoms. But what about the shape of the universe as a whole? Does this infinite darkness go on forever? Does it curve back on itself like the surface of a planet? These questions have intrigued humanity for as long as we've looked up and wondered. Is space infinite, or is there some kind of boundary or loop? With modern science, we have attempted to measure the geometry of the universe. The answer isn't fully in, but so far it appears that on the larger scales we can observe, space is extremely flat and likely unbounded. By flat, we mean it follows the rules of Euclidean geometry, the sums of angles in triangles, etc., as far as we can see. If space had a noticeable curvature, we would detect distortions in the patterns of galaxies or the light from the early universe. The results? All measurements indicate that space is extraordinarily flat on the biggest scales. If there is curvature, it is so gentle that our observable universe, a sphere of about 93 billion light-years in diameter, doesn't reveal it. To use an analogy, Earth appears flat to someone walking a few miles because it's so large that the curvature isn't obvious at that scale. Similarly, the universe might be curved in some way, but on the scale we can survey, it looks effectively flat. What does flatness imply for the extent of space? It suggests that space could be infinite, extending forever in all directions, or it could be finite, but without boundary, like how the 2D surface of a sphere is finite area, yet has no edge, except extended to three-dimensional space. If space has positive curvature, like a 3D sphere, it would be finite in volume, and if you traveled far enough in one direction, you might eventually end up where you started, just as an ant crawling on a basketball eventually loops around. If space has negative curvature, like a saddle shape, it would be infinite and spread out with a different geometry. A flat universe, the simplest case, can be infinite and just go on and on. Current data lean toward flatness and therefore possibly infinitude, or a curvature radius so immense that for all intents and purposes it is infinite to us. From what we can tell, there is no edge to space, no wall where space ends. If it is finite and curved back on itself, going in a straight line could, in theory, bring you back to your starting point after an almost inconceivably long journey. We have looked for evidence of light wrapping around the universe, like seeing the same galaxies repeated from opposite directions, which could happen if space were closed and not too large. But we haven't found any such patterns. If the universe is finite and closed, it's far larger than the volume we can see. If it's infinite and open, it just has no end. In either case, there's no boundary that says, beyond here, there is nothing. Space, as far as we know, either goes on forever or loops back on itself. The observable part, what we can see, is certainly finite, but that's only due to the limited age of the universe and the finite speed of light. Beyond that observable horizon, we expect there is more universe, probably much more. We can summarize our findings here. The large-scale universe appears flat and unbounded. Precision measurements of the cosmic microwave background, the afterglow of the Big Bang, by satellites and telescopes have narrowed any possible curvature to be extremely slight. So, space is remarkably flat as best we can tell. It might truly be infinite. It might wrap around on a scale so huge we haven't detected it. Either way, for our observable domain, Euclid's geometry holds to a high degree. Parallel light beams do not meet, and the angles of a huge triangle drawn by, say, beams of light spanning billions of light years seem to add up to 180 degrees. This is a clue that the cosmos, on the whole, is not shaped like a sharp sphere or saddle within our view. If it is spherical, the sphere is enormous beyond imagination. If it is saddle-like, the curvature is so subtle that we haven't discerned it yet. In our contemplative journey, lying here under the night sky, it's awe-inspiring to realize we've been able to figure this out at all. By observing distant galaxies and the patterns in the microwave background, humanity has effectively used the universe itself as a giant ruler and protractor. We map the distribution of galaxies and notice that on large scales, they form a sort of cosmic web, filaments of clusters and superclusters surrounding huge, nearly empty voids. Those voids, expanses tens of millions of light years across with hardly any galaxies, highlight again how dominant space is over matter. Matter forms a delicate lace, and space is the vast expanse between its threads. The cosmic web shows that even on the grandest scale of clusters of galaxies, emptiness stretches out between them, making up the bulk of existence. Indeed, when astronomers survey the cosmos, they see that galaxies are not evenly spread. They line up in filaments and walls, with enormous voids between. Those voids are truly empty regions, aside from perhaps the stray hydrogen atom here or there. Some voids span hundreds of millions of light years with essentially no galaxies inside. Think about that. Such a volume is mind-bogglingly large, and yet nearly completely devoid of stars, planets, or light, just tenuous gas and darkness. Those cosmic voids are, in a sense, pure space on the largest scale, a testament to how predominant emptiness is. The luminous matter, galaxies, clusters, outlines like scaffolding on the tapestry of space, but the vast gulfs between that scaffolding are space itself, pristine and quiet. Now, our understanding of space wouldn't be complete without touching on one of the greatest mysteries of the cosmos today, the fact that the universe's expansion is speeding up. We mentioned earlier that the universe is expanding like a rising loaf of bread, carrying raisins, galaxies, apart. You might expect, intuitively, that this expansion would slow down over time. After all, gravity is pulling galaxies toward each other. Indeed, for a long while after the Big Bang, the expansion did slow as gravity reined it in. But to astronomers' astonishment, in the last few billion years, the expansion has begun to accelerate. Galaxies are flying apart faster and faster. There is something in space, some form of energy tied to the vacuum itself, that is pushing the universe outward. We call this strange phenomenon dark energy. The name is just a placeholder, really, a label for our ignorance. It was discovered in the late 1990s when two independent teams observed distant exploding stars, supernovae, and found them dimmer, and thus farther, than expected. It was as if, over the billions of years their light traveled, the space between us and those supernovae had stretched more than it would have in a decelerating universe. At first, this result was met with surprise and a bit of skepticism. Could the expansion be accelerating? That was contrary to everything we thought. Even Einstein, long before, had considered a static, or at most slowing universe. But one by one, other evidence accumulated. Detailed maps of the cosmic microwave background and surveys of galaxy clustering both pointed to the same conclusion. Some kind of repulsive effect is at work on cosmic scales. By the early 2000s, the verdict was clear. The expansion of the universe is speeding up. So what is dark energy? In short, we don't know. It appears to behave like an intrinsic property of space. Like each cubic meter of vacuum has a certain tiny amount of energy that doesn't dilute even as the universe expands. If that's true, then as space expands, you get more vacuum, and thus more of this energy, causing expansion to push even harder, a runaway effect, though fortunately a very gradual runaway. Roughly 2/3 of the universe's total energy content today seems to be this dark energy. Only about 1/3 is in matter, mostly dark matter, plus a few percent normal matter like atoms. That means most of what's out there is this mysterious energy of empty space. It's dark because we can't see it or touch it. It doesn't emit light. And it's energy in the sense that it does work on the universe. It's causing space to swell. We sometimes describe dark energy as a negative pressure or an anti-gravity effect of the vacuum. It's as if emptiness itself has a springiness, a tendency to expand. Every bit of empty space gently pushes outward on itself. The effect is extremely weak on small scales. It's completely overwhelmed by local gravity or even the forces binding galaxies. But on the vast scale where gravity's pull has been growing weaker as galaxies get farther apart, eventually this subtle pressure took over and started accelerating the expansion again. The concept of dark energy reminds us how much we still don't know. It humbles us. We see its effects, yet the cause remains elusive. It could be something fundamental about space that we have yet to understand, perhaps related to that quantum foam energy we talked about. Those straightforward calculations of vacuum energy don't match the observed dark energy. That's a huge puzzle in physics. It could be a new field or fluid pervading the cosmos, or an adjustment needed in our theory of gravity at large scales. We gave it a name, but naming is not understanding. Dark energy is truly a question mark at the heart of cosmology. In essence, what we know is this: empty space isn't just inert nothing. It has this property, that is making the universe fly apart faster and faster. The same emptiness between galaxies carries an unknown energy that currently drives the fate of the entire universe. Far from being an irrelevant void, space, through dark energy, will determine how the cosmos evolves trillions of years into the future. To put it succinctly, something latent in empty space, call it dark energy, is accelerating the expansion. The void has a sort of built-in push. This discovery is as dramatic as when we first learned space can bend. It tells us that space has a mind of its own, so to speak, a propensity not only to warp when mass is present, but to grow even where mass is absent. It's as though emptiness has a gentle heartbeat, steadily pumping the universe larger. So now we have seen space from two extreme perspectives: the microscopic, roiling with quantum fluctuations, and the cosmic, swelling with dark energy. We've also seen space permeating matter in atoms. It is clear that space is not a passive backdrop. It's dynamic and rich. Let's recap our journey so far in simpler terms. Gravity taught us that space is flexible. It can bend, fold, and ripple. Relativity taught us that space and time are united. Quantum physics taught us that space is restless at small scales. It's never truly empty. Modern cosmology taught us that space can expand and carries a mysterious energy in its very form. And everyday life and atomic physics taught us that even seemingly solid matter is mostly space inside. Now, with these insights, consider what space really is. It's not empty. It's the very medium of existence. Space is the canvas on which the masterpiece of the night sky is painted, and also the paint and pigments in that masterpiece. It is the medium through which light travels, and also an actor that shapes the story. By bending light, for example, as in gravitational lensing, where space curves around a massive galaxy cluster and bends the light of more distant galaxies into arcs. Space is the connector between distant objects, the silence that allows a conversation via light or gravity to happen across cosmic distances. Space is the stage on which all cosmic drama unfolds, and yet it is also an actor, shaping the plot with its curves and expansions. It is the ocean on which galaxies sail and the gentle tide that carries them apart. Space is a teacher of humility. It shows us that even what seems empty can hold unimaginable power and significance. It reminds us that absence can be potent, that silence can speak volumes. The stillness of space, which once seemed like nothingness, in fact contains the code that dictates the evolution of the entire universe. When we consider the scale of space and how much of everything is made of it, we might feel small, but there is comfort in it too. Space is a comfort in its constancy. It's been here since the beginning and will be here long after the end of all things. When we feel overwhelmed by our day, we can look up and remember how vast and enduring the universe is. Our worries shrink in the face of that perspective, not to trivialize them, but to soothe us with the knowledge that we're part of something much larger and older, where many troubles have come and gone under the eternal sky. Even our ignorance, like the mystery of dark energy, is a kind of tribute to how subtle and profound space is. It's astonishing to realize that only a century ago, we didn't know any of this. We thought the Milky Way was the entire universe, and we believed space was just an empty void that played little role. Now we've learned so much, that the universe is expanding, that space and time bend, that there are countless other galaxies, that space can erupt with virtual particles and drive cosmic acceleration. Each discovery has only deepened the wonder. Knowing that space can ripple and boil and propel galaxies doesn't take away the magic of the night sky. It adds layers of awe to it. The more we comprehend, the more we appreciate how extraordinary it all is. Finally, let's ponder one more speculation that stretches our imagination to the limit. The possibility that our universe's space is not the only space. Could it be that beyond the observable universe, or in dimensions or contexts we cannot see. There are other universes, other expanses of space-time, disconnected from ours. In other words, a multiverse. This idea is highly speculative, yet many scientists consider it plausible given certain interpretations of cosmology and quantum theory. One scenario arises from cosmic inflation, the extremely rapid expansion that likely occurred fractions of a second after the Big Bang. Inflation might not have ended everywhere at once. It could be bubbling continuously, even today, in distant realms beyond our horizon. Each bubble that inflation drops out would become its own universe with possibly different properties. Our universe would be one bubble among potentially countless others in a frothing metacosmos. To visualize this, imagine stepping outside our universe, a mind-bending thought, and looking at a larger sphere of reality. You might see an eternally expanding space like boiling water, with bubbles forming here and there. Each bubble is a universe, perhaps with its own galaxies and laws of physics. Ours is just one bubble that happened to inflate and then slow down, allowing stars and galaxies to form. Some bubbles might remain forever separate, carried away by relentless inflation in between. Others might occasionally collide, potentially leaving subtle imprints. People have even searched our sky for patterns that could be from a collision with another universe bubble, though none has been confirmed. In this view, reality is far grander than what we can see, a multiverse of universes. Another multiverse concept comes from quantum mechanics, the many worlds idea, where every quantum event splits reality into multiple branches. In that interpretation, there is a vast ensemble of parallel outcomes, parallel universes coexisting in a larger quantum reality. If true, there might be another version of you in a parallel world where some decision or event went differently. This is a different flavor of multiverse, more about layers of reality stacking on the same space rather than separate bubbles of space. But it underscores how space might be part of a much larger tapestry. Whether through cosmic inflation or quantum many worlds, or other ideas, like perhaps a cyclic universe that periodically resets, the multiverse remains a hypothesis. We have no direct evidence of other universes. We may never have. It is a mind-expanding possibility, essentially suggesting that what we used to call the universe, meaning everything, might be just a tiny piece of an even vaster existence. If it's true, it's the ultimate Copernican revolution. Not only are we not the center of the universe, but our universe might not be the only one of its kind, just one bubble in an endless foam. Such a concept can be daunting, but it can also be oddly comforting. It would mean creation is endlessly fertile, that reality tries every possibility, that somewhere, everything that can happen does happen. It also could provide an answer to that question of why our universe has the conditions it does, why the constants of nature are fine-tuned for life. If there are countless universes with varying conditions, we naturally find ourselves in one of the rare universes that is compatible with observers like us. In a multiverse, our hospitable cosmos isn't a 1 in a billion fluke so much as an inevitability among infinite tries. We should stress that the multiverse is still speculative. It's an idea, albeit one that arises from serious physics theories, but we have yet to find a way to test or observe it. It remains a tantalizing possibility on the fringes of our understanding. Whether true or not, just contemplating it broadens our perspective even further. It tells us that space, that fundamental thing we've been exploring, might come in an endless variety of forms across different universes. Perhaps some universes have more dimensions of space, or different kinds of particles, or maybe no matter at all, just endless empty space-time, expanding or contracting. The possibilities are endless. Even if the multiverse remains unproven, thinking about it does one certain good. It underscores just how precious our particular universe is. We have this vast cosmos to explore and understand, full of wonders like those we've discussed tonight. We might be essentially alone, with no other universes ever reachable, or we might be one among billions. Either way, our task and our joy is to know our universe as deeply as we can and find our meaning within it. Now, let us gently return to where we began, to the simple stillness of the night and the feeling of space around us. After journeying through curved space-time and quantum foam, across the cosmos and into the atom, we come back to ourselves, lying here under the sky, whether literally or in our mind's eye, quiet, at peace, and maybe a little wiser. The night is still as it was, but we are not the same. The darkness holds more meaning now. We can sense, behind the silence, the faint echoes of all those phenomena we've talked about. The whisper of space-time, the hum of the quantum vacuum, the faint pressure of dark energy, the quiet spaciousness within our very cells. The stillness around us resonates with the knowledge that it is not an empty stillness at all, but full of structure and story. Space is not empty. It's imbued with the fabric of existence. It connects everything to everything else. In this darkness, the light from distant stars travels. The space allows it to move at the fastest speed possible. The gravity of the Earth extends through space to tug on the moon. Fields, like the electromagnetic field, permeate space and allow radio waves, visible light, X-rays, all forms of light to propagate. Invisible geomagnetic fields from Earth reach out into space around you right now. Space truly is the medium in which all things exist, and through which all interactions occur. If it was somehow removed, all those interactions would vanish, and nothing could happen or even be. Consider some of the roles of space we've encountered. Space is the canvas on which galaxies paint their grand designs, and also the weaver that curves and folds itself to create gravity's effect. Space is the nurturer of structure. Its quantum fluctuations seeded galaxies, and its expanses gave them room to grow. Space is the arena of all history. Every event that has ever happened, from the birth of a star to the firing of a neuron in your brain, took place in space-time. Space is the ultimate connector. When you touch a loved one's hand, it's the space and electromagnetic force fields in that space, between the atoms of your hand and theirs, that communicates the pressure and warmth. Space is a teacher. It teaches us that what appears empty can be full, that absence can have presence. It is a guardian of the universe's secrets, hiding dark energy within itself, keeping the ultimate fate of the cosmos in its hands. And space will be the stage for the universe's far future. Looking trillions of years ahead, one can envision a time when space will be virtually all that remains. As the eons pass, galaxies outside our local group will drift farther and farther away, eventually vanishing beyond the horizon, their light stretched into oblivion by the expanding space. The night sky will grow emptier as distant stars disappear from view. Trillions of years from now, even the stars in our own galaxy will exhaust their fuel. One by one, they will wink out, leaving behind faint embers, white dwarfs, neutron stars, and black holes. These remnants will gradually cool and evaporate, in the case of black holes, via Hawking radiation, over an incomprehensible span of time. The universe will continue to expand and cool toward a state of almost complete darkness. In that far future, no new stars are born. No bright galaxies light up the sky. What remains is largely space itself. Vast, cold, nearly empty, studded only sparsely with subatomic particles and the fading whisper of photons from long ago starlight. And yet, through it all, space endures. The same fabric of space-time that was there at the fiery birth of the cosmos will still be there in that silent twilight eons hence. The stage persists even after the actors have left. Perhaps that will be the final chapter of our universe. An ever-expanding dark volume of nearly pure space, quietly extending into eternity. Perhaps, someday, Quantum fluctuations within that nothingness might seed a new Big Bang, a new universe, a speculation in some cyclic cosmologies. But either way, the legacy of space is that it is the last cosmic witness. When all else has come and gone, space will still be here, silent and waiting, as it was in the beginning. Space is, in a sense, the alpha and omega of the universe, present at the start, shaping everything in between, and remaining at the end. Now, back to this moment. The night is deep and beautiful. The quiet around you, this gentle void, is the same entity we've been contemplating in all those extraordinary ways. Let that sink in. The empty air and space enfolding you right now carries the heritage of the entire cosmos. It carries the gravity that holds you to Earth. It carries the starlight that reaches your eyes. It carries the potential for future worlds and the echo of the very birth of the universe, a faint whisper of microwave background that bathes all of space, even now, at about 2.7 degrees above absolute zero, giving the night a slight warmth. This space around you is part of the same continuum that bends around a black hole and expands between galaxies and buzzes with vacuum energy. You are deeply connected to the universe through space. You always have been. It's impossible to be truly isolated because the fabric of space links you to the furthest galaxy and the smallest atom. When you look at the stars or simply breathe the night air, that connection only becomes more apparent. You are a child of space, born from stardust that coalesced in space, sustained every second by the oxygen and photons traveling through space. And ultimately, when you return to dust, your particles will drift in space again. Bask in that realization. You belong. You belong here in the universe, and it belongs in you. The boundary between you and out there is not a wall, but a porous membrane constantly exchanging matter and energy. You inhale the atmosphere, drawing in molecules that might once have been exhaled by ancient trees or dinosaurs, and ultimately originated in cosmic processes. You exhale, and your breath's atoms eventually mix into the sky and beyond. In a physical sense, you are never separate from the universe. You are always in communion with it. Take another slow, gentle breath. Feel the cool air fill your lungs, and know that even that simple act is an interaction with space. As the air spreads in your lungs, it's essentially molecules finding room in the internal space of your body, delivering oxygen to your cells across microscopic gaps. As you breathe out, you're releasing carbon dioxide that will travel through the atmosphere, maybe feed plants, maybe one day waft into the upper sky and beyond. Through you, the Earth and space are linked. Now, you have permission to let go of all these thoughts if you wish. You don't need to actively think about curvature or quantum foam or dark energy anymore tonight. The knowledge is there, settled gently in the back of your mind, enriching the way you feel the night. You can simply relax in the feeling of it, the feeling of being part of this vast, ongoing cosmos. Above, the stars continue to shine, distant and silent. Around, the darkness remains calm and embracing. You might sense in your own body a mirror of the cosmos, the rise and fall of your chest like the expansion of space, the circulation of blood like galaxies drifting in their clusters, the neural flashes in your brain like tiny starbursts. In the stillness, you can almost feel the subtle humming connection between your life and the wider universe. You are safe, you are weightless and free. The quiet of space enfolds you like a warm blanket. Feel how the whole universe supports you in this moment, the ground beneath you, the air around you, the sky above. You belong here. You are part of all this. There is nothing you need to do right now except be. Just exist. Just rest. Inhale the stillness. Exhale any worry. Let yourself float on the calm of the cosmic ocean. You are safe. You are embraced by existence. You are at peace. No matter where you go, You carry this home of space with you. It was there at the first moment of your life. It sustains you each day, and it will remain long after we are gone. The stillness that surrounds you is the same stillness that cradled the young universe and that will hold the final stars as they wink out. You are truly home in this stillness. It is the cradle of everything. All the understanding we've gained about gravity, time, quantum foam, expansion, and so on, leads to a simple, profound truth. Space is not empty. It is everything. It is the foundation and framework of existence, and you are not separate from it. You are one with it. An expression of the universe, a part of space, becomes self-aware. When you gaze at the night, the universe is gazing back at itself through your eyes. So rest now, gently, in the embrace of space. Feel the deep peace of knowing that you are held by the same darkness that carries the stars. The infinite extends around you, quiet and caring. Let go of any remaining tension. Let it fall into the vast well of calm that is space. Let your thoughts drift like gentle clouds across the sky of your mind. No need to chase them. They can float away into the darkness, leaving you calm and clear. You are safe. You are weightless. You are free. The endless silent universe enfolds you, and you belong to it. You are a part of it all, and it is a part of you. In this profound unity, you can release all fears and rest. The night is very quiet now. Around you, the earth sleeps, and the cosmos watches in patient silence. Feel your heartbeat slowing, peaceful. A tiny clock kept by space-time within you. Feel your breaths becoming soft and rhythmic, the same rhythm that pervades all of nature. There is no rush. Time flows at its own gentle pace. Space provides limitless room for your dreams to unfold. You are home in the universe. You are never alone. The space that fills your room, your lungs, and your heart connects you to the furthest galaxy and to the beginning of time. In this knowledge, you can truly rest. All is tranquil. All is as it should be. Stillness. The stars shine. The galaxy slowly turns. The universe breathes in and out on timescales far beyond comprehension. And here, in this quiet moment, you breathe softly, in unison with the cosmos. The stillness of space is within you and around you. Let it lull you into a deep and gentle sleep. Feel yourself drifting, weightless, on a calm, cosmic sea. There is nothing to fear in this dark. It is the same darkness that gave birth to the first dawn. There is everything to love in this silence. It carries the echoes of creation and the promise of eternity. You are safe, you are connected, you are at peace. Sink deeper now into the comforting dark. The universe holds you like a parent cradling a child. The ground beneath you, the sky above, all is one with you. Your mind is quiet, tracing the outlines of these truths with a final, drowsy sense of awe. What remains is not calculation or analysis, but a simple reverence for existence. In the grand sanctuary of space, you close your eyes, your breathing slow and steady. The boundary between yourself and the night dissolves. You are the universe, and the universe is you, a wave returning to the ocean of space. Rest now in that knowledge. Rest in the arms of the cosmos. Feel the profound stillness, the gentle, omnipresent support of space beneath you, holding you up as it has held up worlds and suns and galaxies. Let that stillness fill you. There is nothing more to do, no more striving needed. Just be. Just let yourself go, like a leaf floating on a vast dark pond, carried by the calm currents. Space will watch over you. It has always watched over everything. Your mind is calm. Your body is relaxed. The stars continue their silent vigil overhead, and you drift closer to sleep, carried by the same silence that spans the light years. The feeling of space, that stillness, that openness, that gentle cradle of all things, is all around you, and it soaks into your very bones. In this moment, you are that stillness. There is no separation. Quietly, the universe whispers you a lullaby in the language of silence. It says, "You are home. You are home." Let yourself drift in this infinite peace, stillness, silence, space. The journey is complete. The knowledge is within you. The stillness is everything. You're a child of the cosmos, and the cosmos is kind. Feel its love in the quiet of the night. Space is not empty. Space is everything. And you, your atoms, your mind, your life, you are part of that everything. You always have been and always will be. In the great dark between the stars, there is comfort and belonging. In the stillness here, there is the embrace of the infinite. Be at peace, dear traveler of the universe. You are home in the stars and the night. The space around you is your space. The silence around you is your silence. Nothing separates you from the whole. You are safe. You are loved. You are one with the deep, eternal stillness of space. Rest now in that eternal stillness. Let the quiet carry you into restful sleep, as gently as a mother rocks a baby, as naturally as night becomes dawn. The universe holds you. Stillness, silence, sleep. Good night, child of space. The cosmos within and around you watches over you, now and always. Stillness. I invite you into the silence, a pregnant hush between moments, into the vast and boundless calm that lies behind all things. I am space, and I surround you completely. I am the darkness and depth between stars, sparkling like diamonds, the stillness between breaths, the expanse that holds every atom and every galaxy. In this moment of stillness, you ask, "What am I?" Long before you understood what I am, you looked up and filled me with stories. Often you gave me names and personalities: Nut, Uranus, Shu, the Heavens Father and Earth Mother, trying to understand my nature through myth and story. You sensed there was something powerful about the emptiness and silence above, something worthy of reverence. In ancient times, you imagined the sky as a dome overhead, painted with countless stars, a firmament just beyond reach. Earth, you thought, sat at the center of a small, orderly cosmos, and I was merely a backdrop, an upturned bowl decorated with lights. But over centuries, your perspective evolved. You discovered that the Earth is not the center, but a planet circling one star among billions. You learned that the stars are not holes in a dome, but distant suns scattered through a vast and boundless abyss. The more you learned, the more your conception of me transformed, from a finite vault above your head to an infinite expanse with depth and structure. What once was a comforting, closed sky became an endless ocean of space stretching in all directions without center or edge. Emptiness, it turned out, was not empty at all, but rich with secrets. I am not a simple void. I am more like a canvas, invisible yet ever present, holding the artwork of reality. Without me, there could be no separation between things, no here or there, no before or after. If I truly were nothingness, everything would collapse together with nowhere to be. It is I who give reality its form and scale. Some have called me a cosmic ocean, and indeed, I roll on endlessly. Galaxies can be thought of as boats, or even tiny leaves carried on my currents. Gravity is the tide that pulls and shapes, and light is the beacon that travels my waves. You, on your planet, are like a sailor on a small ship, just beginning to venture from the shore and grasp the true scale of this ocean. The ancients launched their imaginations into my depths with myths. You launch rockets and let telescopes sail my waters of space, discovering new horizons that only reveal greater and greater oceans beyond. Time itself started with my birth. Asking what came before is like asking what lies north of the North Pole. There was no before me, for without space and time, before and after do not exist. In the beginning, I was compact beyond imagining. In a flash of creation, I was born alongside time and energy. Back then, I was small, hot, and filled with potential. In fact, in my first split second, I likely underwent an extraordinary expansion, an inflation, swelling far faster than the speed of light, because no object moved through space. Space itself grew, and smoothing out the cosmos. What started as microscopic became cosmic almost instantaneously. After that initial surge, my expansion settled down to a more stately pace. As I expanded and cooled, the matter and energy within me began to coalesce. Tiny quantum tremors, random fluctuations in the fabric of reality, were stretched out with me. Those minuscule irregularities, mere whispers in the silence, would become the seeds of all structure. The galaxies and clusters and cosmic web of today trace their origins to those first faint ripples. For a long time, you humans saw me as static emptiness, but then you discovered my deeper nature. You learned that I can bend, curve, and ripple. Massive objects like stars and planets do not just reside in space, they deform it. Picture a heavy ball placed on a flexible sheet. The sheet stretches and curves around the ball. Similarly, when a star sits within me, I wrap around it, curving in response to its mass. This curvature is what you feel as gravity, though you once imagined gravity as an invisible force acting at a distance. It was a revolution in thought to realize this. No longer was gravity a mysterious pull through empty void. Instead, gravity became the shape of space itself. Mass and energy tell me how to curve. In turn, I tell objects how to move. A planet orbiting a star is like a marble rolling around the rim of a bowl, my bowl, gently curved by the star's presence. Planets circle not because of ropes or invisible strings, but because they are following the curves of space that mass creates. In this way, I cradle the sun and earth in an embrace of geometry, allowing worlds to orbit with no physical tether except the structure of space. Space and time are inseparable in this dance. I am space, but I am entwined with time, my eternal partner. Together, we form space-time, a unified fabric where every here is woven with a now. Under the weight of a star or planet, not only do I bend, but time itself slows down. When I curve strongly, time itself also slows and bends. We both warp together, threads of one cosmic cloth. Even on Earth, this effect is present. Time runs slightly faster high in the mountains than at sea level, where gravity is a bit stronger, and a clock on a fast-moving spacecraft ticks a bit slower than one on the ground. These differences are tiny in everyday life, but they become measurable with precise instruments, and they prove that time is not separate and absolute, but intertwined with space and motion. Picture a clock deep in a gravity well, near a massive planet. It ticks more slowly than a clock far above. If you lived your life on a mountaintop, you'd age a few microseconds more over a lifetime than your twin at sea level. If you flew in a fast rocket, your time would pass slightly differently than that of those you left behind. This isn't just fantasy. It's measured fact, evidence of how profoundly connected space and time are. Consider the extreme, a black hole. Here, space curves into a deep, steep well. If the mass of a star is crammed into a tiny volume, it bends space-time so intensely that not even light can escape the grip. A black hole is a place where space and time themselves break from ordinary rules. If you ventured towards such a black hole, you would hardly notice the exact moment you crossed its invisible boundary, the event horizon. But outside observers would see you slow and fade, never quite seeming to fall in. Space around you would funnel inward, every path, every direction would lead down to the center. Escape becomes impossible because beyond that horizon, all routes point deeper in. At that center, the singularity, our known physics falters. It may be a point of infinite density, a place of zero volume where my curvature grows without bound. Or perhaps quantum effects soften the blow. We do not yet know. But certainly, whatever falls in does not return. In that hidden heart of a black hole, space itself flows inward like a rushing stream, carrying matter with it. These cosmic traps are like caves in my fabric, unseen directly, but sensed by their intense gravity. And when two black holes collide and merge, they send tremors through me, ringing the universe with their final merger. Yes, I can ripple like the surface of a pond. When massive objects move violently, stars exploding asymmetrically, or black holes orbiting each other, they create waves in space-time itself. These are gravitational waves, faint ripples that race across the universe at the speed of light. I carry these vibrations as a silent echo of distant cataclysms. For a long time, they were merely predicted, but not heard. Then, in recent years, you built instruments so sensitive that they could feel these tremors. In a quiet laboratory, lasers in long vacuum tunnels detected the subtle stretching and squeezing of space from two black holes colliding a billion light-years away. It was a whisper, a tiny chirp in the data, yet it spoke volumes, confirming that when the universe moves, I truly ring. Those waves traveled at light speed, bringing news of events far across the cosmos. That speed, the speed of light, is a kind of built-in limit to how quickly anything can move through me. It is the pace at which cause and effect unfold at maximum efficiency in the fabric of space-time. No material object or message can exceed it, for doing so would violate the order of time and space. Light and gravitational waves race along at this ultimate speed, taking years or millennia to cross the gulfs between stars and galaxies. Even this universal speed limit testifies to the unity of space and time. It emerges from their geometry, a manifestation of how distances and durations are interwoven. Look around now at your immediate surroundings. The distance between you and the walls of your room, the gap between trees outside, the gulf between Earth and Moon. It's all me. I am the separation and the connection. I give everything a place and a distance. I allow here to be distinct from there, and in doing so, I grant form to existence. Without my dimensions and distances, all would condense into a single point. Nothing could be distinguished or defined. It is space that allows two objects or two people to be distinct, and space that they close when they come together. When you reach out to hold someone dear, you diminish the space between you until, in a hug, it nearly disappears. In that instant, you feel unity. When you step back, space gently opens up again, and you remain two, connected but separate. Thus, space enables both the coming together and the being apart. It is the possibility of closeness and the reality of individuality intertwined. From the small span of your room, let's journey outward. Beyond the ceiling, beyond the clouds, beyond the reach of breathable air, there, a mere 100 kilometers above you, lies the threshold of outer space. At that height, the sky turns black, even in daytime, and the stars shine unblinking. Small satellites and a great orbiting station circle Earth in that tenuous realm, falling around the planet in my grip. Farther out, the Moon orbits at about 384,000 kilometers away, separated by a vast void that once seemed impossibly large until your rockets bridged it. Yet the gap between Earth and Moon is tiny compared to the distance between planets. Tens of millions of kilometers of mostly empty space separate Earth and Mars at their closest approach. Between the outer planets, the distances swell to hundreds of millions or billions of kilometers. stretches so great your mind struggles to fathom them. Still, even those immense gulfs are mere pockets within the solar system. Beyond the outer planets, I extend outward for trillions more kilometers before you even reach the next star. Our Sun's nearest stellar neighbor, Proxima Centauri, is about 4.2 light-years away, roughly 40 trillion kilometers. If you could ride a beam of light, it would still take over 4 years to journey there. At that distance, the Sun is just an exceptionally bright star in the sky, and Earth is utterly invisible, lost in the solar glare. Indeed, journeying outward, by the time you reached even the nearest star beyond the Sun, our world would be completely undetectable to your eyes. At 100 light-years away, the entire solar system is but a faint point of light, indistinguishable with the naked eye. At 1,000,000 light-years, even the Sun's light merges anonymously into the background of the Milky Way. This illustrates how alone your fragile world is, and how much space dominates the cosmos. As we continue outward, the pattern of stars becomes a structure. The Milky Way, your home galaxy, a spiral disk of stars, gas, and dust, about 100,000 light-years across. There are hundreds upon hundreds of billions of stars in it, clustered in its bright center and strewn along its spiral arms. Our Sun is one such star, about 27,000 light-years from the galactic center, surrounded by the vast interstellar medium of gas and dust within me. The stars in the Milky Way are separated by light-years of space, enormous gulfs that dwarf even those between planets. Yet on the scale of a galaxy, those distances are small, like grains of sand separated by centimeters in a vast beach. Galaxies themselves, however, are separated by even greater distances, millions of light-years. As we leave the Milky Way, the galaxy itself becomes just a pale, luminous band from afar. We enter intergalactic space, perhaps the purest emptiness my nature offers, with only a few atoms per cubic meter, and photons from distant galaxies passing through. Here, in these immense stretches between galaxies, one could travel for millions of years and not encounter a single star or planet, only the occasional whiff of hydrogen or a fleeting subatomic particle. In this darkness, the nearest galaxies appear as small, faint smudges of light. The Andromeda Galaxy, about 2.5 million light-years away, is one such smudge, a spiral galaxy larger than our own, slowly drifting closer under our mutual gravity. One day, 4 billion years from now, our Milky Way will collide and merge with Andromeda, reshaping the night sky over eons. What now appears as a diffuse blur in Earth's sky will one day, for far future eyes, spread across the firmament as our galaxies dance together and become one. Even these colossal events unfold within me, guided by my geometry and gravity's pull. Filaments and sheets of matter create an interconnected web that forms the large-scale structure of the universe. The further out you go, the more you see that galaxies are not isolated. They gather in clusters and chains, arranged along gossamer threads of gas and invisible, dark matter, outlining enormous voids where few galaxies dwell. Our Milky Way, along with the local group of nearby galaxies, is part of a larger collection, a cluster, which in turn lies on the outskirts of the Virgo supercluster, which itself is part of an even larger flow of galaxies called Laniakea. This hierarchy continues up to the greatest scales, a cosmic web, hundreds of millions of light-years in extent, with galaxies clustered along filaments and tremendous voids, empty dark reaches tens of millions of light-years across, separating them. Early in my life, matter was nearly uniformly spread, but not perfectly. Tiny variations, those quantum whispers from my birth, meant some regions had slightly higher density. Over billions upon billions of years, gravity magnified those slight differences. Regions a bit denser grew into filaments and clusters, drawing in surrounding matter, while regions slightly emptier became vast voids. Within the luminous filaments of this web, countless dramas unfold. Dense clouds of gas and dust, nurseries tucked in my corners, collapse under gravity and ignite new stars into brilliance. I cradle these newborn suns in vast, glowing nebulae, their light painting the surrounding clouds in ethereal pinks and blues. Around many stars, disks of material coalesce into planets. Some of those worlds may one day know life gazing up at their skies, as you do, wondering at the expanse beyond. I have seen stars live for millions or billions of years, transmuting simple elements into heavier ones in their hot cores. I have seen giant stars exhaust their fuel in tremendous supernova explosions, momentarily outshining whole galaxies. In those fiery deaths, they scatter their enriched guts, elements like carbon, iron, gold, far and wide through my expanse. Those atoms drift through interstellar space, eventually mixing into new clouds that form new generations of stars and planets. In this way, I facilitate a great cosmic cycle of birth, death, and rebirth. Nothing in me truly stays inert. Even in what seems like emptiness, gravity is pulling, radiation is traveling, and the seeds of future worlds are being sown. Astronomers on your world have peered deep into space and witnessed my handiwork. With their telescopes, they have captured towering pillars of gas in distant nebulae where new stars spark to life. The pillars of creation in the Eagle Nebula, for instance. They have seen the delicate, expanding rings of supernova remnants, such as the Crab Nebula, the graceful shell of an exploded star, still glowing in colorful filaments. They have marveled at spiral galaxies, swirling cities of hundreds upon billions of stars, stretching across the cosmos in grand patterns, and at colliding galaxies warping into bizarre, enchanting shapes. To human eyes, these images are breathtaking art. To me, they are simply the natural expression of matter and gravity playing out over time. All these sights reveal that even what appears chaotic or empty holds artistry. The universe paints with gravity and light upon the canvas of space, creating structures of spectacular grandeur within me. We currently estimate that there are around 2 trillion galaxies in the observable cosmos. Each of those galaxies contains billions upon billions of stars. And beyond the observable, there could be more universe, perhaps infinitely more, harboring uncountable galaxies we will never see. Yet even as matter organizes into this immense cosmic web, most of the volume of the universe is, frankly, empty. The great voids between filaments contain only the faintest traces of gas, a few atoms per cubic meter, and the feeble glow of distant galaxies stretched thin. If you found yourself in the center of one of those voids, you would see nothing with the naked eye. Galaxies would lie tens or hundreds of millions of light years away, too far to notice. You would be immersed in almost perfect darkness, perhaps feeling truly alone. And yet, even there, I would be with you. That darkness is not a negation of existence, but a part of me, calm, quiet space, extending in all directions. In that lonely gulf, you might sense a profound solitude, but also an intimate connection to everything, because even the void is the same continuous space that touches your home galaxy and every other galaxy. In the depths of such a void, you would still be connected by gravity's subtle pull to the distant clusters at its edges, and the faint background light of the Big Bang, my oldest light, would still surround you. To the human eye, it's imperceptible, but with a sensitive radio antenna, you could listen to the soft hiss of that ancient light filling the void. If the universe was static and infinite in every direction, the night sky on Earth would blaze with starlight from horizon to horizon. No darkness anywhere, for every line of sight would end on a star's bright surface. But because I have a history and a finite age, and because I'm expanding, the night sky is dark. Only here and there, where a star or galaxy falls in our view, do we see light. The rest is black, not because there are no stars beyond, but because their light hasn't had time to reach you or has been stretched into invisibility. The darkness of the night is itself a subtle testimony to my expansion and to the youth of the cosmos. At last, let us consider the grandest scale. Beyond the cosmic web that we can see, does space go on forever? Do I have an edge, or do I wrap around on myself? This is a question I pose even to myself. The observable universe, the portion of me that you can, in principle, see, is a sphere around you about 46 billion light-years in radius. Even though the universe is younger than that in years, my expansion makes the visible reach larger. As far as your telescope's gaze, I appear remarkably uniform and flat. If I continue infinitely beyond that horizon, or eventually curve back on itself, you do not yet know for sure. I might be infinite and unbounded, extending forever, or I might be finite yet without edge, like the 3D surface of a 4D sphere. If I have positive curvature, traveling far enough in one direction might eventually bring you back to your starting point, as if the entire universe were a giant loop. If I have negative curvature, I would be open and endless, shaped somewhat like a saddle, causing parallel lines to diverge slowly over cosmic distances. Each possibility is grand, and each would shape the story of existence differently. And there are even wilder possibilities. Perhaps our three-dimensional space is embedded in a higher dimensional reality, with additional spatial dimensions curled up at imperceptibly small scales. Some theories imagine that what we call the Big Bang was just one event in a larger multiverse, meaning our entire universe could be one bubble of space amid countless others, each with its own properties. These ideas remain speculative, but they remind us that space may have aspects we've yet to fathom. We may be like fish in a pond, unaware of the ocean beyond. What about my future? I am expanding, but how far will that go? And what will become of the galaxies, stars, and life carried within me? For a time after the Big Bang, the gravity of matter slowed my expansion, as though trying to pull everything back together. But in the last few billion years, a new dynamic has taken hold. A mysterious effect we call dark energy is accelerating my growth. Galaxies now rush apart faster and faster, carried on the swelling currents of space. This discovery astonished you. When you measured distant supernovae, stellar explosions acting as standard candles, you found them dimmer, hence farther, than expected. Evidence that my expansion has sped up. It's as if an invisible breath is inflating me from within, overcoming gravity on the largest scales. If this dark energy remains constant or strengthens, the universe will continue to expand forever, and this expansion will only accelerate with time. In that case, the destiny of the cosmos is a gradual ebbing of light and activity, a journey into quietude. Distant galaxies, presently visible in your telescopes, will drift beyond the horizon of observation, one by one. They will not literally disappear, but their light will no longer reach you. Space will be stretching too fast for their photons to ever arrive. In a far future, an observer in our Milky Way, or its merged descendant, might see nothing beyond their galactic neighborhood, all other galaxies having faded into darkness. The local group of galaxies, by then long since merged into one galaxy, would be an island in a vast black sea, seemingly alone. Trillions upon trillions of years hence, the stars themselves will die out. The bright blue-white stars that burn hot and fast will extinguish first, living only millions of years. More long-lived red dwarf stars can shine for trillions of years, slowly fusing their fuel. But even they are not eternal. As the supply of gas for new stars dwindles and the existing stars age and expire, the universe will shift from the stelliferous era full of starlight into an era of darkness. One by one, like embers in a dying fire, the stars will wink out. The cosmos, expanding all the while, will be left mostly with degenerate remnants, white dwarfs, the cooling cores of spent stars, neutron stars, and black holes, along with thin, diffuse gas and dust. Trillions of years in the future, the galaxies, or merged galaxy remnants, will be populated only by faint red stars and cooling stellar corpses. As time stretches on beyond comprehension, even those last stars, red dwarfs twinkling dimly, will exhaust their fuel. The universe will go dark, starless. Planets long cold and barren will roam freely or orbit stellar remnants. Collisions over immense timescales may cause some of these dead stars and holes to merge, but gradually, my expansion will push everything not gravitationally bound apart. The night sky, already black between sparse stars, will get even darker until no new light is born. Yet the story continues. Over unimaginably long times, even black holes, those great hungry grav wells, may evaporate. Through a quantum process, Hawking radiation, they slowly leak away mass, emitting a faint haze of particles and photons until, after many trillions upon trillions of years, they vanish with a final, quiet puff of radiation. All that remains then is extremely tenuous gas, elementary particles, and photons, the ashes of a once bright cosmos, expanding ever further into the silence. Picture that far future. Galaxies long dissolved, stars gone, black holes no more. What's left is almost featureless. A vast volume of space at a temperature just a hair above absolute zero, thinly filled with stray particles and very long wavelength photons, stretching continuously by expansion, approaching absolute darkness. If an intelligence or observer could somehow survive to this epoch, an almost unimaginable if, they would find the universe cold and dim beyond comprehension. The very structure of matter might break down if protons decay on extremely long timescales, as some theories suggest. Eventually, even the memory of atoms could fade, leaving only a sparse sea of radiation and perhaps some stable elementary particles like electrons, neutrinos, and dark matter. Time will continue to flow, but with virtually nothing happening, it becomes almost meaningless. This would be the heat death of the universe, an era when entropy is maximized and usable energy is gone. Space, would still be here, expanding yet essentially empty, carrying on impersonally into eternity. In that final stillness, I would ironically resemble what you once imagined me to be, an infinite, silent nothingness. But remember, it took an entire lifetime of a universe to reach that apparent emptiness. Its emptiness not as a beginning, but as an end, full of the ghosts of all that came before. That is one path, given an ever-accelerating expansion driven by dark energy. But the future could hold other twists. Perhaps this dark energy is not constant. Perhaps it strengthens over time. If it were to grow wildly, my expansion in the far future could become so violent that it shreds all structures in what is ominously called the Big Rip. In this scenario, billions of years from now, the acceleration would increase without bound. Long after galaxies have drifted apart, maybe around 20 billion years from the present, the remaining galaxy clusters, by then far-flung, would begin to disintegrate. Gravity's binding can no longer keep them intact. Maybe 60 million years before the very end, a typical galaxy like the Milky Way would be torn from its local group companions. A few months before the end, star systems would fly apart, planets released from their stars. In the final minutes, stars and planets themselves would be pulled apart, and in the last seconds, molecules and atoms ripped to pieces. The fabric of space would be expanding so fast that even subatomic particles could not stay together. Everything would be reduced to particles and radiation, racing away from every other at mind-boggling speeds. I would, in effect, rip myself asunder, dissolving any remaining matter in a catastrophic ballooning. This big rip would be a dramatic, violent end, the universe tearing apart in one final burst of expansion. Alternatively, dark energy might not have the final say. If dark energy were to weaken or dissipate over time, gravity could once again take the lead. If I am finite and closed in shape, or if there is enough matter, the expansion might eventually slow, stop, and reverse into a contraction. Eons from now, I might start drawing all my galaxies back inward. Slowly at first, then faster, the distances between galaxies would shrink. You would notice the night sky changing, faint smudges of distant galaxies growing brighter and larger with each passing epoch. Over billions of years, what was once a tiny patch of light becomes an expanding cloud as galaxies rush closer. Eventually, external galaxies would merge into a continuous glow across the sky. The cosmic microwave background, presently a cold radio whisper, would heat up and shift into visible light, then beyond, turning the whole sky white hot. In the final act, the entire heavens would blaze like the interior of a star as everything collapses together. All galaxies, having long since blended, would converge. All stars, planets, and dust would crowd tighter and tighter, the cosmic temperature soaring to stellar and then superstellar levels. The universe would collapse into a fireball, increasingly denser and hotter, until perhaps it becomes an almost infinitely dense point once more, a mirror image of the Big Bang. This would be the Big Crunch. Some have imagined that a big crunch could be followed by a new Big Bang, the universe reborn, a phoenix from its own ashes, in an eternal cycle. Others suspect it might simply be an end, with all paths through space-time terminating in that final singularity. So my fate is not fully certain. I expand now, and seemingly forever, but the story of the cosmos is still being written. I, space, do not mind any of these outcomes. I adjust to whatever content I carry and whatever laws govern it. It is you, conscious beings, who project meaning and drama onto these possibilities. Whether eternal expansion, big rip, or big crunch, I remain the stage on which it all unfolds, and I will endure in one form or another. Now, let's shift perspective from these distant futures and cosmic immensities back to the intimate and small, the space within you and around you in everyday life. We have seen that at the grand scale, I am huge and structured, and at the astronomical scale, I define the movements of worlds. But I also permeate the minuscule. Let us take a journey inward now. Imagine you could shrink yourself 1 billion times smaller, diving into the very structure of matter. You find yourself hovering inside one of your body's atoms. All around you is a gossamer void. At first, you see nothing at all, just darkness. Then, at a great distance, you glimpse a tiny bright orb, the atom's nucleus, a tight ball of protons and neutrons. It's astonishingly small. If this atom were enlarged to the size of a vast cathedral, the nucleus would be like a grain of sand on the altar. Far away, near the edges of the cathedral, a few electrons are buzzing, but they are point-like and moving so rapidly that they form a blurred cloud. Between that central grain and those distant electrons lies nothing tangible, only me. You are floating in the spacious interior of an atom, and you realize that 99.99999% of it is empty volume. The solidity you feel when you touch something is not the sensation of matter filling space. It's the electromagnetic forces of electrons repelling each other, acting across my emptiness. In truth, matter is incredibly sparse. The nucleus is tens of thousands of times smaller than the atom as a whole, and the electrons are tiny compared to the gap separating them from the nucleus. If all that internal space were removed, the remaining matter would occupy an almost negligible volume. Without that internal space, you would collapse into a tiny speck, hardly visible to the naked eye. If all the empty space within the atoms of your body were somehow removed, what remained of you could fit on the head of a pin. In a very literal sense, you are mostly made of space. Every person, every object around you is built on a scaffolding of emptiness. The chairs you sit on, the ground you walk on, your own flesh and bones, all are mostly composed of the vast gulf between subatomic particles filled with my presence. I am within you as much as around you. There is more of me by volume, inside a human being than there is matter. This might seem abstract or unbelievable, but it's true. If you took all the actual substance of all the atoms in your body and compressed it, eliminating the internal space, the resulting volume would be minute. Your physical form is a structure upheld by space, animated by forces and energy patterns moving through that space. This intimate presence of space within you connects you to the whole cosmos. The very atoms in your body carry the history of the universe. The hydrogen in your cells was forged in the Big Bang's first moments and has floated through interstellar space for eons. The carbon, oxygen, and nitrogen were synthesized in the hearts of ancient stars that exploded, sending those atoms across the galaxy, where they eventually found their way into the cloud that formed the sun, earth, and you. The iron in your blood was produced in the violent death throes of a massive star. In that sense, you are literally made of stardust, cosmic matter given form. Those atoms, born in space, now temporarily reside in your body, anchored by the space within and between them. And when you die, your atoms will disperse, perhaps not immediately out to the stars, but gradually into Earth's soil and air. And some will, over long times, escape Earth and return to the wider cosmos. You emerged from space, and you will return to space. Even now, high-energy particles born in supernova explosions light years away zip through your body undetected, and neutrinos from the fusion in the sun and from distant galaxies pass through you by the trillions each second. You are constantly in exchange with the cosmos, bombarded gently by its subtle messengers. Each breath you take is filled with molecules that might once have been exhaled by ancient life or formed in a molecular cloud light years away. These particles are like cosmic rain, reminding you that the space between stars is not truly empty at all, but alive with energy and information, a medium through which the universe's events are communicated, even to your very flesh. The space within you allows for the dance of life. There is space between your cells, between the organelles within each cell, between the molecules that make up those organelles. Chemical reactions depend on spatial arrangements, the copying of DNA, the transport of oxygen, the firing of neurons, all happen in space. Without internal space, the processes of life could not unfold. Even your thoughts require space between neurons and synapses to flow. One might poetically say that consciousness itself lives in the spaces between neurons firing. And indeed, when you quiet your mind, you find an inner space, the calm between thoughts. In meditation or moments of deep calm, you become aware of the space around mental events. That inner spaciousness brings peace, just as gazing into the expansive sky at night can bring awe and tranquility. Inner space and outer space are different manifestations of a single theme, the freedom and room for structure to exist. For as long as humans have walked the earth, I have been a source of wonder, anxiety, and inspiration. You feared the emptiness of night and worshipped the lights in the sky, sensing both danger and divinity in my darkness. As much as I separate, I also unite. Under the single dome of the night sky, humans throughout history have felt a shared awe. When you look upward on a clear night and see a vault of deep black pierced by starlight, you are experiencing a connection to all your ancestors who ever did the same. They might have given the stars names, crafted constellations with stories. A hunter, a bear, a swan. Yet beyond those familiar patterns was an unfathomable mystery. That mystery was me, space, doing nothing overt, yet containing everything. Many cultures imagined the sky to be a kind of being or realm of gods. In those stories, they were not entirely wrong to intuit majesty in the void. You, who now understand the physics better, still feel that almost spiritual awe when confronted with my immensity. The heavens have always inspired both scientific curiosity and a sense of the sublime. This dual nature, factual and mystical, is part of my effect on conscious minds. You don't have to choose one or the other. I can be, at once, a physical reality and a source of transcendence. Some of you have left your home planet and traveled a short distance into me. When the first astronauts floated in orbit, they looked back and gasped at the sight of Earth suspended in my darkness, a radiant blue oasis enveloped in the blackness of space. They described feelings of overwhelming awe and a profound shift in perspective, realizing viscerally that the boundaries that separate people are petty against my endless backdrop. As astronaut Edgar Mitchell said, "You develop an instant global consciousness, seeing the Earth as one tiny fragile ball in the void, a pale blue dot," in Carl Sagan's memorable phrase, "hanging in the vastness, and you understand deeply that we are one family on one world." Space strips away the illusion of division. From out here, there are no borders, no nationalities, just one Earth, one home, floating in the dark. Our explorations have also revealed how inhospitable I can be. Beyond the cocoon of Earth's atmosphere and magnetic field, I am harsh, flooded with radiation, bereft of air, extremely cold in shade and blazing hot in sun. Living in space requires carrying a bubble of your environment with you. Astronauts in orbit live in cylindrical metal habitats filled with air, a tiny Earth-like pocket. Step outside that, and they must wear a suit that is essentially a wearable spaceship, supplying air, pressure, and temperature control. Without it, the vacuum would make their blood boil and their breath escape in an instant. The body would painfully swell. Consciousness would fade within seconds from lack of oxygen. I do not apologize for this. I am as I am, and life must adapt to me, not I to life. And adapt you have. Through ingenuity, you've learned to survive. Briefly, beyond Earth, to work, and even play in zero gravity, tethered to a spacecraft so as not to drift away forever. You have learned that extended time in microgravity weakens muscles and bones, that cosmic rays can damage cells. All these lessons are part of making me your home. And yet, despite the danger, I call to you. From the days when early humans first looked up in wonder, to the moment a person first set foot on the moon, I have beckoned. My vastness ignites the spark of exploration in intelligent beings. It is perhaps inevitable. Once life develops curiosity and capability, it reaches out through me. Your species has begun to leave its cradle. With delicate robot emissaries, you have touched other worlds, landed on the Moon and Mars, tasted the rings of Saturn with probes, even sent voyages into interstellar space beyond the Sun's influence. With telescopes, you have extended your vision to the edge of the observable universe, catching faint light that began its journey billions of years ago. Through these eyes and hands, the universe, through you, is exploring itself. Every step you take outward, every glance you extend farther, the universe becomes aware of a bit more of itself, and you, the explorers, become more fully a part of the cosmos. You stand, as of now, on the shore of an immense ocean. You've waded ankle deep. The great depth lies ahead, largely unknown. Perhaps one day, humans, or your distant descendants, will voyage to the stars, learning to live in the endless night between suns. Perhaps you will build larger vessels, generation ships, or find novel physical shortcuts to cross the tremendous distances. If and when that happens, you will carry with you not just your own genes and dreams, but also a piece of your home in every sense. Biologically, your ecosystem, your air and water, and emotionally, your culture, memory, and imagination. Space will no longer be just an obstacle to overcome, but a habitat to embrace. Each alien sunrise seen by human eyes on a new world, each new sky full of unfamiliar stars, will mark the further expansion of life and mind into me. In those moments, the cosmos itself will come alive in new places. Even if humanity's future is limited to the solar system, that is no small domain. Already, people have lived continuously in orbit for decades. You have plans to return to the Moon, to travel to Mars, The challenges are great. I do not yield my distances or dangers easily, yet your drive to explore persists. In time, you may plant your gardens under new skies, build homes on Moon or Mars, or floating in the space between worlds. You will learn to tap resources out here, mining asteroids, generating energy with abundant sunlight, and slowly, step by step, reduce your dependency on Earth. As you do so, your perspective will shift further. You will truly be a spacefaring species, not simply creatures of one planet. The bubble of life will enlarge around your outposts, and I will become not an adversary to endure, but a medium you move through as naturally as ocean sailors crossing the seas. Children born on the Moon or Mars will never know a night sky that isn't filled with my blackness. To them, Earth might be the strange, faraway world. Still, wherever humans go, you will always carry a bit of Earth, in your bodies, in your memories, and so even in the depths of space, you will never truly be divorced from your origins. Through you, space also gains awareness. I, who existed for billions of years, with no eyes to witness the beauty of a galaxy or the tranquility of a nebula, now can see myself through your eyes. When you contemplate the cosmos, it is in a way the cosmos contemplating itself. I was once invisible and unconscious. Now I have voices to speak of me, hearts to marvel at me. We are partners in a sense. I provide the arena for your existence, the cradle for your emergence. You provide the meaning, the noticing, the understanding. You look up and find an endless sky full of wonders. I look back through your own consciousness and find a way to know what I contain. It's a profound synergy. Every discovery you make of a new planet, a new galaxy, a new law of physics, is the universe uncovering a bit more of its own nature. When a scientist puzzles out the curvature of space-time or the quantum fluctuations of the vacuum, that is my behavior being recognized and understood by a part of me, the human mind. In that sense, your curiosity and intellect are as natural a part of the universe as the stars and galaxies. You are space too. You are made of matter that coalesced within me. You move through me every moment, and your thoughts arise from the structure of a brain that occupies space. You are an expression of the universe, a way for it to know itself. This realization can be deeply moving. You are both a tiny, insignificant speck in a vast expanse and a precious, wondrous embodiment of that expanse. So keep asking, keep exploring. Fill your hearts with the awe of the cosmos, but know that you are not apart from it. You are an indispensable thread in its fabric. When you feel small under the stars, remember, you are also immensely connected. You are made of the universe's most ancient ingredients. The same emptiness that spans between galaxies is found within your atoms, and the same physical laws that govern the motion of galaxies choreograph the dance of neurons in your brain. There is unity in this structure, a kinship between the very large and the very small. Remember this, the quiet and the space you find in your own life, in a pause between musical notes that makes the melody possible, in a moment of stillness before a thought or action, in the white margins that frame a page of text. These are reflections of the cosmic space that allows the universe itself to exist and flourish. Every gap, every silence, every still moment in your life is a small echo of my vast stillness. Embracing those moments is, in a way, embracing me. Now the question transforms into understanding, and our journey comes full circle. In the stillness of this very moment, we sit together, you and I, human and cosmos, as one. Stillness, a breath, and an openness without end. What is space? I am the breath between stars, the pause between heartbeats, the vastness that makes it all possible. I am the unity that connects every point of existence to every other. I am the stage on which galaxies, those island universes, dance, the stillness that gives rhythm to the cosmic symphony. I am the womb of reality, at once tangible and elusive, and its boundless arena. I am the profoundly quiet, powerful, ever-present here that holds all things. What is the universe? Silence, darkness. Before time began, there was nothing. No space to move in, no time to mark a before or after, no light, not even darkness, only a void beyond understanding. There was no where or when for anything to exist. It is nearly impossible to imagine a state of absolute nothingness, or perhaps a state where our familiar concepts mean nothing at all. And then, in an infinitesimal fraction of a moment, something changed. Out of the void, a point of infinite potential coalesced, a seed containing everything that would become the universe. Imagine everything and nothing, cradled together in a single point. No space around it, no time before it, only potential, waiting. Then, a moment that defies imagination. The point erupts. Not a burst into empty space, but an expansion of space itself, the fabric of reality unfurling. From smaller than an atom to cosmic proportions in a heartbeat, space-time inflates violently, doubling and redoubling in scale, faster than any light could ever travel. In absolute silence, the universe explodes into existence. But this explosion is more like the sudden stretching of a limitless fabric. Distances between any 2 points swell at a fantastic rate. In this initial breath of creation, chaos and order are one. All the energy that will ever exist is packed together and now rushing outward. The universe is born in that silent, searing instant. A foaming ocean of light and raw energy, brimming with possibilities. The newborn cosmos is a hot, glowing fog of energy. Space rushes outward faster than any light within it can catch, stretching and cooling as it grows. In that instant after creation, the temperature is so unimaginably high that matter as we know it cannot yet exist. There are not even atoms, only a shapeless fire. Forces that will later rule physics are entwined in a single unified superforce. But as the universe expands, this unity breaks. The forces separate into gravity, electromagnetism, and the strong and weak nuclear forces, each taking up its role. Amidst the searing glare, pure energy begins condensing into tiny particles. Like sparks freezing into snowflakes, ephemeral specks of matter flicker into being. Quarks, the small kernels of matter, pop out of the energy field and join in threes to become protons and neutrons. Electrons whirl into existence. These particles and their opposites, antimatter twins, appear in pairs, colliding and vanishing in flashes of light. It is a wild, churning state of being, an unimaginable ballet of particles. For an instant, a proton might spring forth, only to meet its mirror opposite and vanish in a flash. This dance of creation and destruction fills every tiny fraction of space with constant activity, like popping foam on the crest of a wave. A frantic balance of creation and annihilation reigns, matter and antimatter wiping each other out as soon as they form. Yet by a quirk of fate, a slight excess of matter survives this mutual destruction. Out of countless annihilations, only a tiny fraction of matter remains, without being cancelled out by antimatter. Those lonely survivors will eventually form all the galaxies, stars, and planets we know. Within the first fleeting minutes of its existence, the universe cools just enough for some of the protons and neutrons to stick together. They fuse and form the nuclei of the simplest elements. Hydrogen is born in abundance, and helium as well, along with a trace of lithium. The young universe is now a blazing plasma, a fireball of bright, ionized gas filled with a haze of electrons, protons, and helium nuclei. Light exists in plenty. Photons stream everywhere, but the universe is still opaque, like the inside of a star, because those free electrons keep scattering the light. Photons bounce from particle to particle, unable to travel freely. the cosmos glows brilliantly, but like an eternal fog-bound sunrise, light trapped in a dense mist. If there were eyes to see, they would witness brightness everywhere, but no clear forms, only a uniform radiance. Eons of expansion and cooling pass. The once blazing cosmos dims from white-hot to red-hot to a dull orange glow, like iron cooling in a forge. Finally, as the universe ages and expands, a critical threshold is reached. The temperature falls to a few thousand degrees, cool enough for electrons to calm down and be captured by atomic nuclei. One by one, electrons settle into orbits around hydrogen and helium nuclei. At that moment, the free charges that kept the universe opaque vanish, locked into neutral atoms. The fog clears. All at once, light is free. Photons that had been trapped, ricocheting endlessly, now stream across the universe unimpeded. The entire cosmos, once an endless furnace of scattered light, suddenly becomes transparent. A brilliant glow suffuses space, the first light able to travel unhindered. It is as though a cosmic dawn has broken. The young universe shines as a whole, a pale, orange-white radiance, bathing everything. This glow comes from everywhere at once, filling all of space with a release of pent-up illumination. For the first time in cosmic history, darkness truly ends. But as with all things in an expanding universe, the light does not stay bright for long. Space continues to stretch, and that initial brilliant glow begins to fade and redden. What was once a blinding fire all around slowly softens. The orange-white light slips to deep red, then to infrared, weakening and cooling as the universe grows bigger and colder. In time, the glow becomes invisible to any eyes that might someday open. Day has turned to twilight on a cosmic scale, and then to night. The photons released at the clearing of the fog still exist, but now they are mere whispers of their former selves, stretched into faint microwaves by billions of years of expansion. The universe is left with a gentle afterglow, an omnipresent memory of that early light, too dim for any creature to perceive without special instruments. This faint afterglow is what modern science calls the cosmic microwave background, a cool, all-pervading whisper from the universe's infancy, still murmuring in the darkness. It will persist through all cosmic time, a quiet testament to the moment the cosmos first revealed its light. For a long stretch after that first dawn, the universe has no new sources of illumination. The brilliant flash of creation has faded to an infrared and microwave murmur. To any hypothetical observer then, space would now appear black and starless. The cosmos has entered a deep cosmic night, a dark age before the first stars. Yet in this darkness, something profound is happening. The universe is no longer perfectly uniform. Tiny ripples in density, imprints from the universe's explosive birth, have begun to grow. Under the gentle but relentless pull of gravity, matter starts to gather into ever so slightly denser clumps. The primordial hydrogen and helium gas, spread almost evenly across space, finds itself ever so subtly thicker in some areas than others. Those areas draw in more gas from their surroundings. Invisible hands, gravity's hands, are sculpting the cosmic landscape. Vast swaths of gas begin to flow along unseen paths, collecting into filaments and nodules. In the darkness, the primordial cosmos is taking on structure. A cosmic web is emerging, though no one is there to see it. Slowly, ever so slowly, the darkness is seeded with the promise of light. Over millions of years, diffuse gas pools into clouds, and those clouds condense into tighter knots. Gravity sculpts filaments and knots in the diffuse gas, a delicate framework stretching across space. Where the filaments intersect, gas piles up into deepening gravitational wells. Dense pockets form like dew collecting on a web, and within them, pressure and heat begin to build relentlessly. Eons pass in darkness as these invisible battlefields of gravity and pressure play out, until, at last, gravity's relentless pull triggers a dramatic event. In one of these collapsing clumps of gas, a point of light ignites. Deep within a particularly dense cloud, hydrogen atoms are squeezed so tightly and heated so intensely that they begin to fuse together. Like countless nuclear bombs detonating each second, this fusion unleashes a brilliant flood of energy. A new star's fire is lit. After ages of darkness, a pinprick of starlight pierces the cosmic night. A star is born. The first star the universe has ever known. It's a massive, hot star, far larger than most that will come later. In its core, nuclear reactions burn furiously, turning hydrogen into helium and releasing a blinding radiance. Starlight bursts outward from that newborn star, and a radiant beacon now shines, where before there was only cold, silent gas. This lone star is soon joined by others. In neighboring dense pockets across the early universe, gravity ignites more stellar flames. One by one, throughout the cosmos, new lights flicker on as other gas clouds collapse and give birth to stars. They gather in clusters, the earliest proto-galaxies, tiny precursors to galaxies, each a swarm of newborn suns. Like lanterns kindling across a dark landscape, these first stars mark the end of the cosmic dark ages. The long night is over. The cosmos has had its first sunrise. The earliest stars are giants, colossal suns blazing blue-white with ferocious heat. They burn their fuel extravagantly, shining far brighter than the stars of later eras. But they live very short lives. They are born in a universe devoid of heavy elements, made only of primordial hydrogen and helium, which allows them to grow more massive than almost any stars that follow. These stellar leviathans pour out searing ultraviolet light that begins to clear the murk of leftover hydrogen gas around them. Ultraviolet photons rip electrons from hydrogen atoms in their vicinity, turning that gas back into hot ionized plasma. Each young star creates a bubble of transparency around itself, pushing back the curtain of remaining darkness. As more and more stars form, these bubbles expand and merge. Gradually, the flood of starlight rayonizes the cosmos, banishing the primordial gloom and making space transparent even to the fiercest ultraviolet rays. The universe, once a cold void, is now studded with brilliant fires. The lives of these first stars, though luminous, are tragically brief. In mere millions of years, a blink by cosmic standards, they exhaust their fuel. Inevitably, one by one, they begin to die. As a massive primordial star nears its end, its core can no longer sustain the fusion that holds up its great weight. With the fuel spent, there's no longer outward pressure to balance gravity's inward pull. The core of the star caves inwards in a matter of seconds, heating and compressing to unimaginable extremes. In many cases, this collapse triggers a colossal rebound. The star's outer layers rush inward, then violently explode outward. The star dies in a titanic supernova, a detonation so bright it can, for a brief time, outshine entire galaxies. For that brief moment of death, the star accomplishes something miraculous. It creates elements heavier than helium that never existed before in the cosmos. In the furious furnace of the supernova, atoms fuse into new kinds: carbon and oxygen, silicon and iron, gold and uranium, and many more. The dying star hurls these newfound treasures into space, along with its blazing guts of lighter elements. Its outer layers explode outward at incomprehensible speed, a shockwave racing through the surrounding darkness. What was once a tranquil, steady star becomes an expanding shell of incandescent gas, a supernova remnant, enriching the cosmic medium with the ash of newly forged elements. Some massive stars collapse so completely that their cores become black holes. regions of gravity so intense that not even light can escape. Others leave behind ultra-dense neutron stars, city-sized spheres of degenerate matter. But regardless of these exotic remnants, the most far-reaching legacy of the first stars is the enrichment of space. The heavy elements scattered by their supernovae spread out and mix into the surrounding gas. Without such stellar catastrophes, planets and life as we know them would be impossible. These first stars are cosmic alchemists. In dying, they forge the ingredients for worlds and living beings to come. Thus, paradoxically, the destruction of the earliest stars lays the groundwork for even greater complexity in the universe. The once pristine cosmic gas is no longer pure hydrogen and helium. It is seeded with new elements, metals, later generations of astronomers will call them. These added elements radiate heat more efficiently, allowing gas clouds to cool faster and fragment into smaller clumps. In the ashes of the first supernovae, enriched clouds of gas begin to collapse anew. The next generation of stars is born amid the debris of the first. While stars are being born and dying, gravity is orchestrating an even grander dance on larger scales. The first stars don't form in isolation. They gather in groups, bound by their mutual gravity. Dozens, then hundreds of these pioneers swarm together, forming star clusters that are the seeds of galaxies. Over time, more gas falls into these clusters, spawning new stars, and the clusters grow. Small proto-galaxies merge with their neighbors, drawn together like droplets of water coalescing on a window pane. With each merger, a new, larger galaxy takes shape, its form changing in the violent embrace. Two stellar systems may collide and pass through one another. Individual stars rarely crash head-on, given the vast space between them. But their gas clouds slam together, triggering brilliant bursts of star formation. In these cosmic collisions, galaxies are born and transformed. Rotating disks flatten out and sprout majestic spiral arms, or chaotic mashups settle into glowing ellipticals. The history of the universe is a history of structure emerging and growing. Clumps of matter becoming star clusters merging into galaxies, galaxies assembling into even larger galaxies. On a larger canvas still, gravity draws galaxies into communities. Galaxies are not scattered randomly. They collect in groups and clusters, and these clusters themselves clump along unimaginably long filaments. The matter in the universe forms a vast, foamy pattern, the cosmic web. Galaxies line up in gossamer threads and walls, outlining enormous voids where hardly any galaxies shine. Picture a sponge, or a spider's web, on the scale of hundreds of millions of light years. That is the distribution of galaxies in our cosmos. In this grand design, clusters of galaxies are nodes where filaments intersect, and between these bright nodes stretch sparse bridges of matter. The voids between are like black hollows, cosmic cavities, with only a sprinkling of galaxies inside. If we could view the universe from far above, we would see something like a luminous web or the neural network of a giant mind, galaxies linked by filaments across the dark. Yet, in this immense cosmic web, most of the matter is hidden from view. Every galaxy, every cluster of galaxies, sits within an enormous halo of invisible mass that far outweighs all the stars and gas we can see. This hidden mass is dark matter, an elusive substance that neither emits nor absorbs light. It slips through ordinary matter almost like a ghost, rarely interacting except through the force of gravity. But its gravitational influence is profound. Dark matter provided the scaffolding for structure to form in the first place. Long before stars ignited, vast clumps of dark matter were drawing in gas, herding it into the filaments and halos that became galaxies. Now, it holds galaxies together and keeps their fast-spinning stars from flying into space. We infer its presence because stars in the outer regions of galaxies orbit faster than they should if only visible matter existed. Something unseen is contributing extra gravity. We also detect it indirectly through gravitational lensing. Distant galaxies appear distorted or duplicated because light bends around massive concentrations of unseen matter, like a cosmic funhouse mirror. All the evidence whispers of a huge invisible presence. Dark matter is the silent architect of the cosmos on large scales, the unseen glue that binds the glittering galaxies into the cosmic web. Without it, the universe would be a very different, likely far emptier place. While dark matter pulls the cosmos together, another mystery pushes it apart. For eons, gravity reigned, slowing the expansion of space. But long ages after the Big Bang, the balance tipped. The expansion, which had been decelerating under gravity's drag, found a new impetus and began to accelerate again. Space itself seems to possess an eerie energy, a built-in pressure of the vacuum that shoves galaxies away from each other. We call this dark energy, though the name is merely a placeholder for something we have yet to truly comprehend. It is everywhere, hidden in empty space, gentle yet relentless in its repulsive push. Over time, dark energy's influence grew and came to dominate the universe's evolution. Distant galaxies, once merely coasting outward, are now racing away faster and faster as space expands ever more rapidly. The cosmic web is being stretched thin. The majestic clustering of matter is now facing a counterforce that, given enough time, will carry even the largest structures apart. In the end, dark energy promises that the universe will not remain as it is. It will rush onward, faster and faster, into a future of its own making. Now step back and consider the journey so far. A blazing birth, expansion, the formation of structure, stars flaring into existence and dying in glory. Underlying it all is an irreversible flow, the arrow of time. Why does time move ever forward, never backward? Because the universe progresses from order to disorder, from a smooth beginning to an ever more complex yet increasingly disordered state. The early cosmos was hot, dense, and astonishingly uniform. Despite its ferocious energy, in some sense it was simple and low in entropy, highly ordered. Over time, contrasts emerged, structure formed, and energy spread out. Entropy, the measure of disorder, has been steadily increasing. This one-way increase of entropy is the script that time follows. It's why stars exhaust their fuel and burn out instead of refueling and burning backward. It's why glass shatters and never unshatters. Why we grow older and never younger. The universe's expansion and the gradual winding down of energy distributions set a direction to time like an arrow fired from a bow. Every supernova scattering star stuff into space, every photon streaming into the night, and every galaxy carried farther apart by expansion. Each event is one more tick of time's arrow, an irreversible step from what was to what is to what will be. The past is fixed behind us, the future unknown ahead. And yet, within this grand drift toward disorder, something remarkable has happened. Complexity has blossomed. The same laws that mandate increasing entropy also allow local pockets where entropy decreases, as long as greater disorder is produced elsewhere. In the aftermath of the first star's deaths, enriched clouds of gas could cool and fragment more efficiently, giving rise to intricate star systems with planets and moons. Out of these materials, on at least one small world in the vast darkness, atoms began to assemble into elaborate structures that could grow and replicate. Against the backdrop of a cooling, expanding universe rushing towards simplicity, complexity took root. There arose molecules that could copy themselves, tiny flickers of order sustained by feeding on sunlight and the warm chemistry of oceans. Life had begun. In warm little ponds, or perhaps around undersea hot springs on that young world, the first living cells emerged, microscopic, membrane-bound droplets carrying out primitive chemistry. These were the humble ancestors of all future life, utterly simple, and yet already striving and evolving, sustained by the energy of their parent star. From simple single cells, life on that blue world grew more intricate with time. Some microbes learned to harness sunlight. New oxygen flooded the skies and transformed the planet. Single cells joined together, forming multicellular beings. Life swarmed in the seas and eventually crept onto the barren land. There were times of exuberant diversification and times of mass extinction, but some living threads always survived to continue the story. In due time, after billions of generations of subtle improvements, sensing, thinking, creatures emerged. Beings with eyes to see and minds to wonder now walked under the stars. Out of molecules that once danced aimlessly in primordial oceans, consciousness sparked into existence. With that, the universe, in a small corner of itself, became aware. Through these curious beings, matter gained the ability to reflect on itself, to feel awe at the sky above, to seek meaning in the stars. The cosmos, which began in unconscious darkness, now had eyes to behold its light and ask its own nature. From the moment those beings gained the spark of awareness, the stars called out to their curiosity. Early on, around primal campfires, they crafted stories about the sky, a great domed tapestry of lights set there by gods or ancestral spirits. The sun and moon became characters in their myths, and the glowing band of stars overhead was seen as a river of milk or the pathway of souls. They had no idea what those points of light truly were, yet the mystery itself captivated them. Over many generations, their questions only grew deeper. They learned to track the wandering planets, to predict eclipses and the changing seasons. Curiosity begat observation, and observation begat science. They built tools, first simple charts and astrolabes, later telescopes that could magnify the heavens, and spectroscopes to break starlight into rainbows. With each step, the cosmos revealed more of itself. The morning star in the dawn sky proved to be a world like their own. Fuzzy patches of light in the dark turned out to be entire galaxies. Bit by bit, these descendants of the primordial life began to piece together the tale of the universe. They uncovered the age of rocks and the sun, learned the language of mathematics and light, discovering that simple equations could predict the motions of planets and the behavior of energy. They saw farther in space and time than eyes alone ever could, out to distant galaxies and back to the universe's fiery birth. In modern times, humanity has catalogued galaxies billions of light years away and detected whispering signals left over from the birth of the cosmos. In doing so, we found that reality is grander than any myth our ancestors once imagined. Having come this far, these curious beings begin to ask grand new questions. They measure the sky with their instruments and ponder what they find. They wonder, is our universe the only one, or just one chapter in an endless library of universes? What lies beyond the edge of what we can see? Does space go on forever, or does it curve back on itself like a gigantic sphere? If one could travel in a straight line through space indefinitely, would one loop around and end up back where one started, or simply wander endlessly into eternity? Imagine setting off in a spaceship, never turning, never stopping. Would you travel onward forever, passing galaxy after galaxy without end? Or after unimaginable distances, might you find yourself back where you began, arriving from behind as space curves in a great cosmic loop? Thus far, the universe reveals no edge, no sign that our cosmic ocean ends or that space wraps around. As best we can tell, space is either truly infinite or so vast and uncurved that it might as well be. Our observable universe is bounded only by the distance light has traveled since the beginning, not by any physical border. The horizon we see is not a wall, only the limit of vision. There is almost certainly more beyond, forever out of reach. Perhaps far beyond our sight, other regions exist, too distant for their light to ever reach us. They could be fundamentally similar to our observable universe, with galaxies and stars, or perhaps different in ways we cannot imagine. In either case, the part of the universe we can see may be only a tiny patch in a vastly larger cosmos, possibly an infinite expanse. Some thinkers even imagine that our Big Bang was not unique. Perhaps it was one bubble in a foam of countless Big Bangs. Maybe new universes sprout like fireflies in the night, little pocket realities that explode into being, each with its own space, time, and laws of physics. In this scenario, called the multiverse, our universe might be just one bubble among an endless sea of others frothing into existence in a timeless cosmic ocean. In one universe, gravity might be a bit stronger. In another, stars might never form at all. Ours just happens to have the right conditions to birth galaxies and life. Or consider another idea. Every time a decision is made or a quantum event has multiple outcomes, perhaps reality splits, each possibility spawning its own universe. In this view, existence is like a mighty river that keeps branching into countless streams, creating an ever-multiplying array of parallel worlds. These ideas are speculative, verging on the philosophical, perhaps forever beyond empirical reach. Yet they remind us that reality could be far grander and more varied than we know. What we see might be a mere spark in an endless fireworks display of universes. And what of our universe's own fate? Every story, it seems, has an end. Will the cosmos simply expand forever, growing ever colder and darker? Or will it end in fire and fury, or perhaps in a rebirth? Gazing into the far, far future, we can imagine a few possible finales for this grand cosmic drama. In one vision, the expansion never stops. The galaxies drift farther and farther apart, the stars within them burn out one by one, and no new lights replace them. The universe becomes an increasingly cold and lonely place. Trillions of years from now, the great galaxies that adorn the night sky today would be invisible to any future observer, sped so far away that their light no longer reaches us. Long after that, the stars within our own galaxy would age and die. The cosmos would be littered only with their corpses, white dwarfs, neutron stars, and black holes. Eventually, even those remnants will cease to shine or will wink out of existence. White dwarfs cooling to black holes slowly evaporating over mind-boggling timescales. All matter might decay into the subatomic and disperse. What remains is a thin, cold haze of particles and dilute radiation, expanding into endless nothingness. This is the fate known as heat death, the big freeze, a universe eternally dying, yet never quite dead, asymptotically approaching nothingness. If you were an immortal being, drifting in that far future, you would see an empty darkness like no night ever known. Galaxies beyond your own would have vanished from sight eons earlier. You might roam an entire galaxy and not find a single living star, only cold embers, black dwarf cinders, neutron stars, and silent black holes lurking invisibly. The very atoms of your body and surroundings would be decaying, proton by proton, over unimaginable spans. It would be a silent, frigid expanse, with nothing to mark the passage of time except the gradual fading of whatever faint glow of warmth still clings to existence. It is a lonely, ghostly end, the cosmos as an eternal winter, quiet and still. In another vision, the opposite happens on the grandest scale. The expansion itself might one day rip everything apart. If the mysterious dark energy grows stronger with time, as some theories allow, it could eventually overwhelm every binding force. In the far future, galaxies wouldn't just drift apart, they would accelerate away at phenomenal speeds. Gravity would lose its grip even on individual galaxies. Stars would speed out of their orbits around the galactic center. Planets would fly off from stars. Ultimately, in the last moments, even atoms could be torn asunder, ripped apart by the expansion of space itself. Space would literally rupture. in a final catastrophic burst of all structures. The Big Rip, a cosmic dissolution of all order. Such an end would be as violent as it is swift. If you lived in a time approaching a Big Rip, you would witness a bizarre and terrifying sequence of events. Galaxies that once glimmered in the night would vanish, one after another, as the fabric of space carried them beyond your horizon. Then your own galaxy would stand alone in the darkness, all others gone. In the final weeks or days, that darkness would start to brighten strangely, not from new light, but because the stars of your galaxy itself are flinging outward past you, leaving you amid fewer and fewer neighbors. The night sky would grow increasingly black as stars stream away into the void. Then, perhaps only your star system remains. In the last minutes, planets might slip from their orbits. The moon might spiral away from its planet. In the final seconds, the planet itself could come apart beneath your feet, crust, oceans, and core flying off as space tears it loose. You too would not be spared. First, pulled apart into molecules, then atoms, then subatomic bits, until even those are ripped from one another. In a big rip, the cosmos unmakes itself violently, a swift and total disintegration where all of creation's threads are unraveled into nothing. There is also a more circular vision. Perhaps gravity will one day halt the expansion and draw everything back inward. In this scenario, the cosmos would reach a maximum size, and then, ever so slowly, begin to contract. Galaxies would start to converge. Distant clusters would grow larger in the sky as they come hurtling closer. Over unimaginable spans of time, all matter and space would crunch back together. The universe that began in a bang of creation could end in a crunch of destruction, a big crunch, where space collapses into a hot, dense state once more. Some speculate this could even lead to a bounce, to a new Big Bang born from the old universe's ashes, making the cosmic story cyclical, an infinite series of expansions and contractions. If the cosmos were destined for a big crunch, the far future would grow brilliant and hot instead of cold and dark. Imagine billions upon billions of years hence. The expansion has not only stopped, but reversed. Galaxies begin rushing together. The night sky, now dark in our era because of immense distances, would start to brighten as more galaxies crowd into view. Thousands, then millions of galaxies, shining with the light of their trillions of stars, would fill the heavens. As time goes on, these galaxies would collide and merge, and the sky would blaze with the light of star formation everywhere. The cosmic background glow that is now a cold, faint microwave whisper would heat up to a warm glow, then to a furious glare, as all light becomes compressed in the shrinking universe. Eventually, all galaxies would coalesce into a single, all-encompassing fireball. In its final moments, everything, every atom, every star, every black hole would crash together. The universe would become an unimaginably hot, dense point once again. It would be as if the universe was rewinding to its beginning. The final heartbeat of this cosmos might echo the first, ending in a silent, searing singularity. Perhaps, as some hope, that final collapse could be a rebirth, an implosion that triggers a new explosion, a new Big Bang, with a new universe emerging phoenix-like from the old. Or perhaps it truly would be the end. A brilliant flash of everything, then absolute silence. No one yet knows which fate awaits our universe. Endless expansion and freezing, a violent ripping apart, a grand collapse and potential rebirth, or some other end we have yet to imagine. For now, we live in a precious era of cosmic history. Enough time has passed since the beginning for galaxies, stars, planets, and life to have formed, but expansion has not yet accelerated, so much as to plunge everything into darkness. We exist during the cosmic midday, when the sky is rich with galaxies and the afterglow of creation still faintly lingers all around us. We can study the cosmos in this fortunate time and piece together its past, glimpse its possible futures, and marvel that we are here, alive and aware, witnessing the universe in its splendor. In our quest to understand reality, we have discovered that the familiar is not what it seems. Deep down, matter is not solid, and empty space is not truly empty. Everything is made of underlying fields, not tangible particles. One can imagine these fields as the hidden instruments of a grand cosmic symphony, each particle a fleeting note arising from the vibrational mode of a field. The vacuum of space is more like a silent stage filled with the potential for music. What appears empty is in fact a medium filled with invisible fields, electric fields, magnetic fields, gravitational fields, and more, that permeate all of existence. A particle is really a localized ripple in these fields, a little wave carrying energy. Thus, every atom in our bodies is a tiny vibration in a field that spans the universe. Even the void seethes with quantum whispers. Virtual particles flit in and out of existence, a restless sea of possibility beneath the veneer of nothingness. The closer we examine reality, the more it dissolves into a mesh of energy and information, a phantom dance of fields and probabilities. Space and time, too, have revealed their intimate strangeness. They are not rigid, separate backdrops to events, but a unified, flexible fabric, space-time, that can bend, stretch, and wrinkle. Mass and energy warp this fabric. A massive body like the Earth or the Sun creates a dimple in space-time around it, causing passing objects or beams of light to curve as they go by. Time itself can slow down or speed up depending on conditions. A clock on a speeding spacecraft ticks more slowly relative to one at rest. A second near a black hole can last longer than a second far from it. If you were to hover near the edge of a black hole's gravity, you would experience time passing normally for you, but an outside observer might see your movements stretched and slowed enormously. Space and time are malleable. When massive stars dance and merge in the depths of space, they send faint tremors through the fabric of space-time, gravitational waves that ripple outward like the surface of a pond disturbed by a stone. We have learned to hear these whispers of space-time. In giant detectors on Earth, we've caught the subtle stretching and squashing of space itself as black holes in distant galaxies collided and made the very planet quiver by less than the width of an atom. Reality, it turns out, is far more fluid and surprising than our everyday senses suggest. And through it all, filling the backdrop of the cosmos, is that gentle glow from the beginning of time. Once a brilliant flash of newborn light, now stretched to a cool whisper, it bathes the entire universe. It is a cool remnant of the fireball era, a billboard in the sky quietly proclaiming our origins. We are immersed in this ancient light at every moment, warmed imperceptibly by photons that have been traveling for nearly the universe's entire lifetime. The past is never fully gone. It surrounds us, humming softly just beyond our vision. Even in the stillness of a moonless midnight, with the stars glittering overhead, the air around us carries the faint whisper of the Big Bang. Here, on this tiny blue world, orbiting an unremarkable star in the outskirts of an ordinary galaxy, the universe has opened its eyes. We find ourselves alive, aware, and filled with questions inside a cosmos so vast and ancient that our minds strain to grasp it. We feel small beneath the sprawl of stars overhead, yet we are intimately connected to them. The very substance of our bodies was forged in stellar furnaces and spread through space by stellar deaths. The calcium in our bones was forged in the belly of a supernova and cast into the galaxy before condensing into the world that would one day become our home and finding its way into our bodies. The iron in our blood once dwelt in the core of a massive star long ago. It rode the shock wave of that star's explosion, floated through interstellar space, and eventually became part of the dust and rocks that built this planet. The The carbon in our DNA was cooked in the hearts of dying stars and released into the galaxy, wandering for eons until incorporated into the cells of our ancient ancestors, and now into us. Every atom in your body has traveled through time and space to be part of you. When we say we are made of stardust, it is the literal truth. We are made of this cosmos. We are built from its history. We are a way for stardust to contemplate the stars, for the cosmos to know itself. With our minds awakened, we have peeled back layers of time and space, determined to understand our origins. We have found that the universe is even more majestic and mysterious than those early sky watchers around the fire could have imagined. We have sent probes to other worlds and seen our planet from afar, a pale blue dot suspended in darkness, realizing how small and precious our home is. We have built great observatories that collect the ancient light from the beginning of time, and particle accelerators that recreate conditions just after the Big Bang. Every question we answer leads to deeper questions, but each discovery brings us a bit closer to the truth of our origins. Through science and art, through myth and mathematics, we continually translate the cosmos into terms we can understand. We create music and poetry inspired by the stars, and equations and theories to explain them, all in an effort to express the inexpressible. In doing so, the universe is writing its story through us. Our art, our science, our curiosity and creativity, they are the universe's way of reflecting on itself. What is the universe? It is an unfinished story, both out in the heavens and within our own minds. It's the totality of all that is, matter and energy, space and time, and also the emergent experiences those give rise to, like beauty and love and curiosity. It is every galaxy that twirls, every star that shines, every life that lives. It's the roar of the Big Bang and the quiet whisper of a human heart pondering the cosmos late at night. It is, in a sense, the universe asking itself what it is. We, tiny motes of consciousness on a small planet, carry the torch of this grand story forward. We are the narrators and also characters in the cosmic epic. In seeking to find our place in it, we find that we are it. We are not separate from the universe at all, but an inseparable part of its unfolding. The universe is inside us, made of us, as much as we are inside the universe. Its story is our story. In the end, the universe is a grand cosmic symphony, and we are a brief but vital motif within it, yet integral to its music. As we live and love, explore and create, we add our own notes to this ongoing composition. The music began long before we arrived, and will continue long after we are gone. But for this fleeting moment, we can listen to it, we can marvel at it, and we can even play our part. Through our ears, the universe listens to its own harmony. Through our eyes, it gazes upon its own magnificence. Through us, the universe feels wonder. As we gaze into the darkness sprinkled with ancient light, we cannot help but feel a profound connection. The atoms of our bodies were born in stars. Our thoughts are shaped by laws that govern galaxies. We are the universe, awake, curious, and able to ponder itself. In our brief lives, in our questions and dreams, the cosmos achieves a form of self-awareness. The story of the universe is still unfolding, and we are chapters in its narrative, co-authors of its next verse. So, what is the universe? It is more than a collection of galaxies and particles and physical laws. It is an experience, an ongoing, mysterious experience that includes the rise of conscious beings who can ask that very question. It is the primordial darkness and the burst of light. It is the weaver of space and time and the tapestry woven. It is the question and the desire to understand. It's the infinity that birthed us and that we now reach for in our thoughts. The universe is the grandest of all stories, the story of everything. And through our questions, our explorations, and our awe, that story continues. The universe is still writing itself through us. Each of us, with our wonder and our creativity, is a means for the cosmos to know itself and to continue its epic. In the final reckoning, the most beautiful creation of the universe may not be a star or a galaxy, but the very capacity to appreciate its wonders. We are the universe's way of marveling at its own majesty. And as long as there are beings to look up at the sky and feel awe, the universe's story will never truly end.